inaugural edition of HashiTalks Australia New Zealand 2021. If you're here today, that makes you special because there's only one inaugural edition, because that's how the word works. And we're super excited to have you. I'm one of your hosts, Kareem Satirli. My co-host, Lucky White, is here with me. We are excited to host you today. But before we jump in, a quick word on our code of conduct. In general, we need you to be welcoming, inclusive, friendly, and patient. If you're joining us on YouTube and asking questions there, be considerate, respectful, and professional. We're going to have a ton of fun here. We're going to have good learnings, but this is still a professional type of event, despite us not being professionals. You can review our code of conduct at hashicorp.com/community-guidelines. We'll have a link for that in the chat. And with that, let's get started. First of all, morning, Lucky. Well,
hi, Kareem. How you going?
Good day, probably.
Good day, mate. Good day. It's a good try. We need to work on it. Thicker accent, I think, but today is not a bad start.
It's here. It's too early to get proper, Melbourne magic. So I'm gonna have to get that inspiration in a little while.
As long as you know what that is, that makes me happy. As long as you know what that is, I'm stoked.
It is one of the best changes that you brought to my life. That's what matters. I'm excited to talk more about that later today. In the meantime, if you just happen to be on YouTube and you have no idea what you just clicked on and why we're live and why there's two people talking, this is HashiTalks. This is a community-driven event where we highlight use cases from our practitioners and learnings and everything interesting around our tools. So welcome, grab a beverage. We'll get started in a couple of minutes. We've got our first speaker ready, which is awesome. And that pretty much all that we have. In the meantime, Jesse, if you want to get set up with your slides, since we're doing all of this live, it's the beauty.
It's the only way to do it.
It's the only way, right? Like there is no staging environment for this. We're just gonna Terraform apply auto approve if you're that kind of person.
Right click deploy.
Man, click deploy is definitely an interesting concept. In the case that you are a social media person and you want to tweet along, use hashtag HashiTalks. And if you have something cool to say, or just something quirky, fun, or whatever related to the event, please do that. We'll highlight a couple of the most interesting tweets. And with that, I'm just gonna see, Jesse, are you ready?
Hey, Kareem. So I am nearly ready.
I think nearly ready is kind of like how my infrastructure usually looks like. There's always a little change that I can continue making.
Start the video. All right, sharing my screen. Hopefully you can see my screen and my video and me.
I like that. Nice little round video in there.
Yeah, I got this tip from one of my good ex work colleagues, actually. Bit of an OBS fanatic he is. Just set it up this morning, so hopefully it all works.
I think so far it looks good. Good seeing you. With that, the stage is yours. I'm excited to hear about making my Terraform be less verbose with for each.
Awesome. Well, thank you, Kareem and Lachlan, for the opportunity today to present this. My name is Jesse Loudon. I'm a principal consultant at Lab 3, coming to you live from Sydney, Australia. It is a bit chilly here, so forgive me if I let out some coughs. I'm not sick at all. Just been nursing a cough for the past couple of weeks. So today's session is dry coding with Terraform CSVs for each. I'm pretty passionate about this. I've been using it, this sort of pattern for the past few months, actually. Myself, I've been working with Terraform for about 1 year only. So I'm still a bit of a baby in terms of Terraform expertise. And yeah, I'm really passionate about Microsoft Azure as well. So if you follow me on any social media, you'll notice I'm doing a lot on the sort of Microsoft Azure space. So let's kick on. Initially, when I was coming up with these slides, I kind of wanted to start with, a background of why we do something. So to give you some insights here, the problems that I was solving when I was working on this pattern and looking into if this would work for me, I had a very large problem, and that problem was, well, there was actually multiple problems. I had a lot of data, so I had large scale inputs that I needed to provision into Microsoft Azure. There would be frequent changes to this data, so a lot of adds, updates over time. I wanted to maximize code reusability, and the reason for that is because I've done very opinionated Terraform modules and environments before, and I found that the reusability of those environments was minimal. So I really wanted to start with a vision in mind this time around to maximize my reusability for this Terraform code and for this environment. And I also wanted to minimize coding effort. I don't have a lot of time to spend working on Terraform modules and whatnot. So I wanted to take the learnings from past experience and code that had already been used and built and tested by other people. So it's also very time sensitive in terms of what you're doing. We often don't start with a lot of time budget for working with these kind of projects in mind, if I could say that. So this image here, I think a lot of us can relate to. It's kind of been going around recently. I think it is a good segue into what we're talking about today, how Terraform, the CSV decode function and the for each metadata, the meta argument exactly, can be used to move and unblock your problem, which is large amounts of data. And in this case, I'm going to use CSV to handle that. In your specific use cases, you may look at using perhaps YAML files or JSON or some other sort of data type. So let's kick on here. Now, I want to talk initially about the data. I think this is a good point to start with because, when you have a goal in mind, you don't often start with, oh, I have this Terraform code or this module or this pattern, and I want to look for data to use it with. Often we start with, we have some requirements, so we need to build something. And that means you have some initial data already gathered in terms of what you want to build, right? And then you go start looking at, how do I build that quickly? How do I make the code reusable and as dry as possible? So let's start with the data. Here is an example data set, nicely formatted for easier viewing in this slide. This is a CSV data set. You may not be able to notice because of the sort of table format here, but essentially the basic layout here is that there's a header row, which is that top row there. And each of these values in the header row, so region here on the left column, this is going to be the key for our key value pairs. So region will map to will map to Australia Southeast, Australia East, New Zealand North. New Zealand North doesn't exist yet, but it is coming soon. So I'm kind of like future planning here for when that region is available. Hopefully this slide stands the test of time. Now RG name, that's resource group name. So you can see this is a data set for provisioning resource groups into Azure. And basically each new line under the header row at the top, this represents a new resource in your deployment. So I just want to show this to you to start off with, to kind of set the scene for what's going to come. Now, under the hood, CSV decode as a function, what it's doing is essentially it's taking our CSV rows, the values from the rows, which are comma separated values, and it's converting them into a list, a single list containing multiple maps. So you can see here on the right is the native CSV type data. Not pretty or anything, but it is, I guess, digestible for this slide. So on the left is what you get as an output when you run CSV to code using that data. So you can see how it organizes the data into maps. And this is important to understand because when you're working with CSV to code, you may need to understand how this all works under the hood in terms of troubleshooting why your data is not coming through properly or why resources are not being provisioned as you would expect. So I think this is a good introduction to that. Now, alone by itself, each of these kind of tools, CSV to code and for each, they can be used independently of each other. When I was researching this solution, I actually came across the idea from one of my ex-work colleagues, and I'll link the blog to you later on in this presentation. But really, and this is something I discovered myself after finding that blog, CSV to code and for each, they're kind of like a really good pair. They're better together. HashiCorp Terraform have documentation to back this up where it actually gives you patterns and examples on using both of these together. So that was a really good help for me when I was learning how this would work and kind of finding out, whether this was feasible for my use case. So let's look at an example, some code here, some snippet, just simplified for this example for this session. On the top here, we've got a local variable called RG for resource group. This is using the CSV to code function. It's calling a CSV file which lives in my repository locally. And then the second line below that is actually a module for a resource group, also in my local repository. And it's calling that local variable for RG and basically ingesting it in the format that you saw in the previous slide, where it's a list of maps. Now you may notice this for each expression here. It is doing something other than just referencing the local variable. So if you look at where it shows here, rg.rg name, this is important to note because this actually assigns a unique ID column for your maps that come in through CSV, and that unique ID column is important to assign for your data sets coming in, because as you make changes to that CSV file, maybe you're adding resources, removing resources. If you don't have this unique ID column set as you bring in the data to your resource or your module, it can make it very difficult and very troublesome to actually make changes through Terraform. And I'll give you a demonstration of this as I go along. So you can see here name and location, the different variables being passed into the module here for resource group. They're referencing in each value. So this actually, so the each value.rg name, this is a reference to the column name that you saw on the previous slide. So you do need to make sure as part of your CSV design, your column names, I think, should be consistent. They should have a naming convention. And it also makes it easier when you're designing and maintaining these modules and resources that are using for each based on your CSV inputs, right? So this is kind of like an introduction to how you would go about implementing this from a very simplistic point of view. Now let's talk about how we can use this pattern for the don't repeat yourself methodology. And the example I have here on the screen is, so let's say we have a CSV data set for resource groups or virtual machines. We can call that same CSV data set from multiple modules and resources within our code. And that way we maximize the reusability of the data set. And we're not having to recreate the same amounts of data or code. And it's all minimized and as dry as possible. So let me go to the next slide here. There's a bit more going on this slide, so I apologize for that, but I really tried to condense this down into something which provides the most value for this presentation. So at the top here, in the local variable, I've changed resource group to VM just to show you that we're now pulling in data for a number of virtual machines. And on the right, you can see an example of that data in a nice table format. So what this would do is it actually creates virtual machines. So below that local variable definition, we have a module for a virtual machine. This will be a Windows virtual machine, I think. Notice that it has a depends on statement there, and it will reference a resource group module, which I showed in a previous slide. This is something I found that I needed to do because I'm using CSV data sets and there's no implicit dependency for your resources. So, your data set has a resource group name there that you can see on the right and a virtual machine name, but because it's coming from CSV, Terraform does not create these implicit dependencies between them. So, if I didn't have the resource groups created ahead of time before the virtual machines, sometimes my Terraform deployments would fail. So some notes from the field here. This depends on argument here that I put in. It's very important if you're using this pattern, just to ensure that the underlying required resources are created in the right order. So you can see here again, we got a for each referencing that local VM variable. I'm assigning the unique ID for this for each module to the VM name. And that's important. I don't think you'll have the same virtual machine names in your environment. It's very unlikely. So that's what I've chosen. Now you can see these purple arrows here that I put in are just an example of where we can leverage a dry methodology, a dry pattern for using CSVs and for each. So we've got resource group name here. We've got virtual machine name in this column. And both of these values for this particular resource is going to be used multiple times across multiple modules or resources. And the second resource that will use those values is actually for backup. So this is just an example that I've used in the past. I've created a virtual machine. I've also created a backup object in Azure for that virtual machine. And I've referenced the same data set. So I didn't have to create a new data set containing all the resource group names and virtual machine names and backup policy IDs and all that in a different data set, which I would have to manage. So I've used that same data set here. And what you can see in the source VM ID, I just want to call this out as well. I'm using an expression here. It's kind of like a concatenation string. So it's creating a resource ID using the values from the CSV file. And this is something I've leveraged a number of times to basically keep resource IDs, which can be very, very long. I've used this expression to ensure that the CSV data is as minimal as possible. Because if I had this resource ID defined in my CSV, it would be quite hard to read and manage that. So I've used this concatenation string. I think you should check it out if you're not using that today. It's very useful. So hopefully this gives you an introduction to how we can keep our code and our data as dry as possible. Let's continue on. Lessons learned. So like I said, I've been working on with this kind of pattern for a couple of months, and there's some things that came up repeatedly, and I spent a lot of time kind of troubleshooting and figuring out, why did this break? Why was this issue appearing or something not working? So let me show you some mistakes I made and try and help you to avoid those. So notes from the field here on using CSV to code and for each. A couple of times I had some spaces within my cells, and CSV to code will see that as, so each cell represents a string in your map. And if you have spaces in your string, what it appears like is this representation here. So you can see there's, after the foo, there's some spaces before the string terminates. That represents a problem, especially if your parameters or your arguments for your resource or module, does not support spaces, and that's very, very common with using Terraform. So, a lot of times I'd say, why isn't this working? And it's because of spaces. So I'll show you in the demo how you can prevent that from happening and how you can kind of catch that using.
I think that wasn't you. I think that was what happens when somebody applies live changes to the Zoom infrastructure while other people are doing a live stream. Apologies for that. Whenever you're ready, feel free to rewind yourself in 30 seconds in your head. We'll fix this in post-production because that's the magic of editing. And sorry about that.
Awesome. So yeah, I'm ready now.
Taylor confirming we're good to go. Awesome. Let's do it. This was the best part as well.
So the empty extra cells point here from my learnings using this pattern, empty cells will happen. Sometimes you'll have a column within your CSV data that needs to be empty, or it just doesn't have a value there. And you can use an expression. So you can use a conditional expression in your Terraform module or resource to accommodate for these empty cells. And I'll show you how that works in the next slide or in my demo as well. Now, following on from that, list values, often you'll have, say, for example, if you're creating a virtual network, you'll have DNS servers coming in as part of your virtual network creation. And in the DNS IPs, you'll have multiple IPs, obviously, I hope. So what that gets seen as is, as you can see on the screen here, it gets seen as comma-separated values, but within a single string. Now, when you bring that into your Terraform code, this actually is not an acceptable list because it's a single string. So what we need to do is we need to use the split function within Terraform to actually split up these comma-separated values into multiple strings, which can then be passed into your module or your resource. And finally, last but not least, this unique column changes example here. So before, just a few minutes ago, I mentioned that you can assign a unique column to your for each module or resource. If you make changes to the value of that unique column, so let's say, my unique column is the virtual machine name. If I made a change to the virtual machine name in that column, it would want to recreate the entire resource. And that's really important to understand that the data in that unique column is pretty sacred. The values are pretty sacred. If you're going to change the values in that column and you don't want to recreate the resource, be prepared to do a Terraform state move, for example. So you can move the resource from in your state file from the previous resource name, which will be tied to that unique column ID. Okay, so that pretty much wraps up the sort of top mistakes that I made, and hopefully, this gives you a kind of heads up in advance of you using this if you're not already doing that. So hopefully we have time as well for a quick demo. Let me just minimize this. So I've got Visual Studio Code here. I have a very small proof of concept that I just created ahead of time. And I've run Terraform apply ahead of time as well. You see, you're not waiting for me or the resources to be created as part of the session. So on the screen here, you can see I'm creating resource groups. I'm bringing in some local variable here for RG, similar to what I showed you before. I'm using a resource group module. I'm using the for each expression here. And the unique ID is the RG name. again, very, very similar. And I'm outputting the resource group local variable from CSV to code, just to show you what it looks like. So I've run that already, and you can see here, similar to what I've shown you before, just highlighting here that this is a list. The CSV to code function brings in a list of maps. So each one of these maps represents an individual resource, sorry, an individual resource in your deployment, right? And each one of these keys here, so RG name, region, that's a column within your CSV file. That's the header column, right? And here's the values. So this is a resource group in Australia Southeast named AUS-HashiTalks 01. And there's other resources as well, all uniquely named, but using the same keys there for definition. Now, what I want to show you as well, here's the CSV file. It's local in my repository. So remember I mentioned the unique ID column. So if let's say I change the order of one of these resources, if I just cut this, I'll move that from line 3 in my CSV, I'll move that to line 13, and I'll save that. And in my terminal, I'll go Terraform plan. Now, what should happen, I've moved one of the resources to a different line. And if you're using that unique ID trick that I showed you, what should happen is Terraform plan should not be picking up any changes in terms of having to recreate a resource. So I've run Terraform plan. It's saying here 0 to add, 0 to change, 0 to destroy. You'll notice the outputs have changed because I moved that particular resource to a different row within the CSV data. So that's obviously coming down here. Now I'm using the latest version of Terraform in this demonstration. So this is 0.15.0. So nicely, I do like how it only shows, what has changed, and it hides what hasn't changed. That's a very nice feature of 0.15. Now let's look at another example here. What if I added a new resource? So I'm going to add a new resource here, Southeast AUS HashiTalks. Let's call this 07 as in terms of a resource name. So I've saved that. What if I had a space in my resource name, or what if I had a space in the region? So I'll add in a space here. Maybe I accidentally did this, or perhaps, perhaps someone else did this, or perhaps some automation did this as part of your data generation. So I've saved that file. If I run Terraform plan, it most likely will come up with an error because a space within your region name is not going to be accepted by the module or the resource that you are trying to provision, for example, in this case, to Microsoft Azure. So it should come up with an error. There you go. So the error says that the name, so it's actually mentioning the resource group name here, not the region. I'm not sure if it will mention the region later on after I fix the resource group name. But yeah, it does mention like, oh, this can only contain alphanumeric characters, dashes, underscores, that kind of thing. So here's how you can stop this from happening. Within my own terminal Visual Studio Code, I am using an extension called CSV edit CSV. This extension has been pretty useful. It's created open source by a contributor in the community. And what you can do with this, so if you notice in the bottom of my terminal, if I just zoom in here, these options, so I've got an align option here. That's coming in from the edit CSV extension. So what I can do is I can align all my rows to the columns so it looks nicer, and that makes it easier to edit within my Visual Studio Code window. I can also shrink. So if I click align, it'll change the option to shrink. If I click shrink, it actually removes those spaces that I put in intentionally. And this is a really important point that sometimes you'll be doing edits, lots of edits in your CSV files within Visual Studio Code. And you need to just make sure there's no extra spaces in your cells which are going to cause issues. So I highly recommend this extension. Use the align or shrink. Shrink will remove any extra spaces. So let's save that. And now if I run Terraform plan, it should pick up that I have a new resource. That's the 07 resource group in Australia Southeast. And while that's running, let me show you in the portal. So all these resources were created ahead of time. There we go. So if I go back to my terminal now, it's actually finished that plan and it's picked up that I have a new resource to add. There we go. I'm not going to add that now, but what I will do is I will add a new column and some data for this data set and bring that into my module. So I'm going to do tags. I think this is pretty common. So I'll just remove this commented bit of input here. So I'm going to bring in a tag called cost code, and I'm going to reference a column using each value. And I'm going to name that column tag cost code with no spaces. So if I take this in my CSV, again, this is very useful. If I go edit as CSV using the extension, I can add a new column here. I'll name this exactly what I'm using within the code. So tag cost code. I'll just name this HashiTalks ANZ. How about that? So as I duplicate that down, sorry, this is taking so long, I didn't realize. So that's done. So I've got some values in there. I've got a new tag column, which will come in through CSV to code. I'm going to apply and change that. This is using the edit CSV extension. So I will now look at my raw CSV data here. So you can see my new tag value. I don't believe there's any spaces, so that's good. Now let's do a Terraform plan. And remember, I uncommented the tag input from my module. So this should be picking up that I'm now going to add this tag value from the local variable for resource groups, which uses CSV to code. Now, I don't know if I have time to actually apply this, but let's just see how we go. Okay, so that was pretty quick. So you can see here in my outputs that are coming up, it is going to add the tag cost code to each of these maps, which represents an individual resource. So let's see if I can quickly approve this. Terraform apply, auto approve. And what we should see as I refresh the portal after this deployment finishes, we should see that tag applied to our resources live within the environment. And sometimes, like I mentioned before, you may have cases where you're going to have empty values for these cells. What you can do is you can do a sort of conditional. Okay, that finished the apply. What you can do is you can do a conditional expression. So you can do an if-then expression for these values. So if the value is empty, apply this value, which might be null, or it might be a string or an object or an array, depending on what is required by your modular resource. Or if it's not empty, use the value that's from the cell, if that makes sense. Okay, so that apply has run. And if I refresh, there we go. So if I zoom in here, you can see my cost code tag is coming in from my CSV dataset, HashiTalks ANZ on one of these resource groups. And that's pretty much, that's an example of how I very quickly modified my CSV data to bring in a new element of this environment. And I didn't have to do much coding here. I had a very, kind of minimal parameter bringing the value from that new column into my module. And you can repeat this out as many times as you want across different modules, different resources, and alike. So that pretty much wraps up the demo. It's very simplistic. I think we don't have a lot of time to do much more there. Let me kick on to go back to my slides here. Let me kick on to where do we go from here? So if you're not using CSV to code or for each today, I do highly recommend you go and test it out yourself and see if it can work for you. Certainly, there are some things I haven't had time to mention in this demonstration and session. So it's very interesting to go and do your own research, do your own testing. I think you'll learn a lot that way. And also, don't repeat yourself strategy. This is kind of like, you know, the ultimate mecca, I think, for anyone who works in infrastructure as code, that, you know, we need to kind of have this idea of doing as minimal as possible because of time constraints, because of budget, and because we just don't get a lot of value by repeating the same code or, you know, logic in multiple places, if that makes sense. Look for economies of scale with data sets. So you might have a data set for virtual machines. That same data set, for example, can also be used for your backups if you're creating backups for each of your virtual machines. So that's one example where you don't need to spend time creating a new data set and manage those inputs separately to your virtual machine data set, for example. And beware of those data set gotchas. So on the previous slide, I showed you some mistakes I made. You know, empty cells, spaces in strings, list values not appearing, not being calculated correctly. And also that planning for changes as part of your implementation and design is very important. You know, I think it's very, very rare that you would deploy once, like infrastructure code, you deploy once and then never have to do a change again. This is going to happen, especially in like an agile sort of environment where, you know, you start with a very small design, you kind of rapidly iterate on that design, and you're constantly deploying, looking to, you know, add value constantly rather than just doing a huge design up front. You deploy it once after a few months, and then, you know, that's it. I think that's very uncommon. So definitely plan for changes to your code, plan for changes to your inputs, look for that consistency that you can bake into your design and your code. Lastly, I mentioned before when I was researching this solution, I did come across a blog from one of my ex-work colleagues, Lucian. So just linking that here, if you're looking for some inspiration, Lucian's written a pretty cool introduction to how he used the very similar pattern, CSV files, Terraform, CSV to code, and for each in his use case. I think it was adding routes to a virtual network. So check that out if you have time. And that pretty much wraps up my session. Thank you very much, and take care.
Awesome, Jesse. What an awesome session.
Yeah, absolutely. I love this. Thank you for sharing. Pulling in CSVs like this is super, super painful. I was going to say powerful, but it is also painful, which actually leads me into my favorite slide was probably the costly mistakes one, because you could tell from the title that those learnings did not come cheap.
Yeah, like that was a tough mistake. I mean, I'm constantly learning every day. Like I said, I've only got like 1 year experience with Terraform. So, you know, these are the kind of embarrassing mistakes I made, not knowing how the data comes in from CSV to code. So I think, yeah, hopefully people can learn from that.
I honestly, the error message item may only contain alphanumeric characters and dashes and periods should be on a t-shirt, just because it's like, you won't think about this until it's too late. And at that point, yeah, you've got a pretty nice slide to talk about. It's I love this. Many great call outs. We even had Lucian in the audience. So we'll share the link to the Terraform and CSV equals more Netflix blog post. Yeah, and with that, thank you so much again for sharing. Apologies for the Zoom outage. If you've ever joined us for HashiTalks before, we have this rule that something with either Zoom or YouTube needs to happen during the event to give us a little bit of stress. So thank you for being our testing candidate for that.
Got it out of the way early. Got it out of the way early.
Well,
Hey,
I'm
Jesse,
glad to be the guinea pig.
just like dry coding Terraform with CSVs, right? Jesse, what do you reckon the future of using this is together? Like, I mean, obviously you can hugely scale. Where do you think the benefit of using CSVs potentially to like downstream data calls of the data sets? What do you think the pros and cons with those approaches are?
Yeah, so maybe I didn't cover pros and cons much. I think I missed that slide for some reason. Pros and cons of this is for me, I prefer using CSV for my data sets over YAML. The reason for that, if I have a lot of resources, let's say I have 1,000 resources. So each one of those resources could be, a route. It could be a network security rule. 1,000 resources in a YAML file. It's a very, very long YAML file.
Fun time. Yeah.
And also in a YAML file, the keys, so the key value pairs are duplicated. So the keys for your data is duplicated for each resource. I don't like that. And I've preferred CSV for that reason. I don't have much experience with JSON as a data set, so I can't really comment on that. So also in terms of
great. That's fantastic. Like, I mean, how big a sigh of relief was that finding that extension? I've never seen that extension before in VS Code, and it's like top tip. Like, after this, I'm going to go add it to my VS Code. It's awesome.
Yeah, edit CSV. That's the extension name. Also, it pairs really well with Rainbow CSV, which I didn't demonstrate. Okay. But if you do get edit CSV, it's the extension, definitely get Rainbow CSV. They work very well together, and Rainbow CSV does the highlighting. So the color coding for each individual column within your CSV file. I think that's very important in terms of, user readability.
Yeah, awesome. Well, thank you again so much for sharing, Jesse. It was absolutely awesome to have you in and be a part of HashiTalks 2021. And I can't wait to get the recording of this up and live and start to share this with people, because it's a really cool problem to solve.
Absolutely. Thank you.
So thank you again, and Jesse, and we'll move on to our next presenter, who I'm super excited about, because managing Vault, especially at scale, is something that I end up talking a lot about throughout the day job, and I'm really keen to get some insights from someone who's experienced in this field as Yule and from HashiCorp and run through this. So come back with us in about about a minute, and we'll have Yule presenting on managing Vault at scale.
All right. Welcome, everyone. My name is Yule Liu. I'm a senior solutions engineer at HashiCorp. I'm based in Australia, Sydney, so New South Wales. I look after some of the accounts locally. Today, we're going to talk about managing HashiCorp Vault at scale. But before we go to the scale issue, let's define, what do I really mean by managing HashiCorp Vault? We all know that there are many aspects that you need to do as any big enterprise software with clustering, you need to be careful of initial deployment, the ongoing configuration, the maintenance, patching, backup, restore, your routing test on failover and failback, making sure that the disaster recovery is going to kick in automatically. You need to manage the unseal key, which is the most important thing for Vault, that's guarding the security of Vault itself. And you need to do security auditing all the time just to see if Vault has been hacked somehow. But most of the effort in these items don't really increase with the number of secrets or applications or users that you have onboarded into Vault, except configuration. So that's really what we're talking about. This session will focus on configuration. How do you scale the configuration when you are managing your enterprise Vault, especially when you have a lot of users, sometimes thousands of users, and sometimes thousands of applications that need to onboard. And they all have different kind of requirements. Now, so let's say how users actually configure their Vault today. There are 3 classic ways to configure Vault today. So the first one is obviously the GUI. Vault does provide a web GUI. You can just log in using your tokens or your choice of authentication mechanism. Once you log in, you can configure some aspect of the Vault using the GUI. And obviously there are command lines and APIs. Command lines and APIs can be used to configure all aspects of Vaults. And to further automate this, people actually tend to do automated pipeline. They use command line or API into a pipeline to configure Vault. But both come with problems. So the first problem with the GUI is that it doesn't allow you to configure everything. In fact, I have a screenshot at the bottom. You can see that the database secret engine is not yet supported. But HashiCorp is working to extend that, but there is always something that's not available yet. And plus, configuring using GUI always come with the problem of reliability, consistency, the speed, and human mistakes. So it's always a problem. It wouldn't scale when people need to onboard many applications and users. For APIs, there are other problems. Say, number one, the user really need to be really familiar with command line and or API. So that basically limited the kind of user that can configure Vault to a limited skilled group of people. That's you. And also you would need a privileged access to Vault to be able to configure Vault. Sometimes that means the Vault administrator team will be overburdened with other work. And also just on the API, you need to be keep following the API changes or new features. Whenever there is new feature, there is new API, you need to change your script. And further, if we put this into a pipeline, then someone needs to review the code. Say someone put a JSON code, a policy in JSON that wants your API to apply it. You need to review that every single line of code and making sure that it's in line with your best practice. This could take a lot of effort, but most importantly, the team will become a bottleneck for the enterprise to adopt a Vault. And that's a bottleneck we really want to remove. Now, even in a pipeline-driven command line or API, there are many other issues. But before we get into the issues, let's look at the secrets that's stored in Vault. I personally classify the Vault configuration into the secrets into different categories, 3 different categories. So the first thing are the stuff that should strictly managed by Vault admins, security personnel, Vault admins. So for example, the PKI root and intermediate CA configuration, Obviously, it's super important. It's super sensitive. You don't ever want to leak that private key that's being used by this secrets engine. An audit device is strictly managed by Vault admin. You don't want to add a audit device that's pointing to somewhere else. So suddenly people have audit logs of what happened to your Vault. And authentication mechanism, generally that's limited to administrators, especially AD, because that's group-wide configuration. Now, there are some applications or secrets that should really only be used or managed by the user. Say, for example, you have an application team today saying, I want to onboard my application into Vault. Number one, I need to make sure that no one else reads my secrets. No one else outside of my group can read these secrets. But also for these secrets, I may have a different access. Say, for example, in the team, we have a secret admin who can write a secret, but he can never read a secret. We have the application that can read the secrets, but they don't need to change the secrets. And maybe we have something else that's an application owner can both read and write as a break glass procedure, something like that. And then there are some secrets that's sitting in between. So PKI rules, for example, an application can come in and request, I want to get PKI certificate for my group of servers. This is the kind of host name I want to add, right? So, and also namespaces. Say, for example, if your organization have multiple business units, namespace as a top-level logical separation inside Vault can be used to segregate different business units. So no one can see the secrets from other namespaces. So the things in between are actually stuff that can be requested by users and and then approved by admin. So if we look at this secrets, the requirements on this managing of these secrets, obviously the first group is, I want to hide every single implementation detail of this. It shouldn't be seen by any other one. And for the secrets that strictly managed application, I only want to make this available to application based on different rule. They have read or write or both read and write access. And for the next one, application can actually see what's there, and then they can send a request, and then admin can approve whether that request is accepted or not. So looking at this, we have different categories of secrets. They need to be managed differently, which means putting them into a pipeline-driven command line or API in a single pipeline isn't not going to work. So you must have multiple pipelines. And sometimes every application may need their own pipeline. Say an internet banking team comes along. He needs a namespace. He sits in the retail banking group. He will have a namespace called retail banking, and then he have an application that's called internet banking inside that namespace. And he wants to manage the policies, the access to that path all by itself. That means you have multiple pipelines, potentially up to thousands. And then you need to worry about the access to each of the pipeline, the configuration of the pipeline, with the resource repository, with the destination and namespace. And then the data sharing between different pipes. So for example, we mentioned that the PKI role should be a shared resource. Every user can request, then request to a common PKI secret engine, and admin can approve, right? So there are many things to consider. And also different pipelines will have secrets, and not only configuration, you have secrets. Now, given this, you end up with thousands of pipelines. It's just too hard to manage. It's almost impossible to manage, in fact. So now, so the solution really, the first part of the solution is Terraform provider. So we know Terraform have many providers, in fact, 400 plus providers. So in this case, we could use Terraform providers to build a simple pipeline just using GitHub as a source repository and the Vault as the management system. And in between, we have Terraform Enterprise. So Terraform providers will manage all the pipeline. It will define the source code and convert them into a Vault API calls and apply that to Vault. That's the first part of the solution. In this one, we are addressing the issue of where you have to follow the Vault API. So if you use the Vault API, Vault provider, you no longer need to follow API because that's all abstracted within the Terraform provider. And that Terraform provider is actually published by HashiCorp. Now, the solution 2 is really the one that's sitting in the middle, the Terraform Enterprise. So we are using multiple features of Terraform Enterprise to manage this. So the first one is the multiple pipeline. In our case, you can call this as a multiple workspace, Terraform workspace. So Terraform workspace and VCS integration will be used to configure different categories of Vault resources. So itself will act as a pipeline. And of course, when you configure the Vault, you need some credentials, you need some other stuff. You need credentials to manage a GitHub as well. So the secrets to this resources or the target system can be stored inside Terraform Vault as a secure variable so that no one can read apart from the Terraform instance or the Terraform Docker container that's going to be run by Terraform Enterprise. The next one is the private module. Private module can be used to hide sensitive implementation details. So the user only need to know how to use the module, what's the input, what's the output. It doesn't have access to how the implementation details is done. So this will hide the details on, say, for example, the PKI secrets engine, the intermediate CA, and authentication mechanism details. So your OU groups and stuff like that. Lastly, policy as code. So we don't, as the administrator, we don't want to review every line of code. If we do have a policy as a code engine that's sitting there, automatically govern the code and see what can be configured and what can be requested from both security and operational aspects, then that will reduce the burden on the group of Vault admins. So as long as you can request your code, as long as it passes all the security policy, then you'll be fine. You can be automatically, your change can be automatically approved, automatically applied to Vault. So that's the part 2 of the solution. So without further ado, let me do a small demo. I built this demo earlier today, and I had a number of applies. So let's have a look. So first, let's look at the Vault itself. So I do have a Vault. Let me log in. This Vault runs locally as a VM. So once you log in, you can see that this Vault have in the PKI certificate encryption engine and some authentication mechanism already configured. These are configured as part of my shared services Terraform code. So let's look at the beginning. So for the code, all I need is I need to manage Vault, I need to manage Terraform, and I need to manage GitHub. That's it. Then I define my authentication engine, GitHub authentication engine, or the root CA and intermediate CA and stuff. And also, let's say, Vault audit device. But I'm putting all this into a super secure repository that is only limited to the Vault admins. Then I'm going to link this to my Terraform management workspace. Inside this workspace, I would have all my secrets configured. So this is not a secret. This is just a reference. For all the secrets, I have basically marked them as sensitive. Once it's marked as sensitive, then no one can really read the secrets. Even admins can only write, but it will be made available when you run the Terraform, when you queue the job. Now let's see, for example, I have my main code. So this is my modules. We mentioned before that we're using private modules to hide implementation details. So in this case, I have a module, and I'm going to output the module outcome. So I'm creating, basically, I'm requesting a namespace that's called HashiTalks, and that's it. So for the purpose of the demo, I wouldn't create a pull request. I'll just commit directly to the master branch. So once I commit the code and push it to GitHub, GitHub will let my no, it's here. Oh, this one. It will notice the change. It's changed. It's committed a few seconds ago, and then it will pick up the code and it will run the code. Just let's do a refresh. Okay, so it's doing the planning and apply. Within a few minutes, it will be done. So while we are here, we can actually see right now we have no namespaces. And if we wait for the run to finish, it's taking a little while. All right, so it's going to add some resources. So those resources, let's have a look at the plan. So we know that it will add a GitHub repo. That is the place where we can, the repository we can give to the security admin of that given namespace, HashiTalks. And then after that module is added, after the repo is added, we will add some Terraform workspace. Inside this workspace, we will define some variables. That's basically the secrets for that namespace to be able to control, for Terraform to be able to control the given namespace. And then we have some policies. Those policies, we create a token. We will create a token. I'll create a vault token. Let me see where the vault token. Yeah, so we will create a vault admin token for that given namespace that is only limited to the namespace that we have requested. So there is a lot of details inside. And then after the resources, we will then link that to the namespace. So the end result is that you will end up with let's do a refresh. So we end up with a HashiTalk repository. This repository is only created 42 seconds ago. Inside this code, we have some initial code for providers and stuff like that. And then in the namespace, let's see if we have namespace now. Now we can see that this namespace has been actually created for us as well. This namespace will be given to the namespace admins. That's a security admin that's below the global Vault admin. So this workspace, this run has finished, and we actually have some usage message. So your namespace is ready, and all you need to do is to commit your code into this repository. So let's have a look. So that's the code. Now let's say if I want to use this code as the admin, I can onboard my applications. So in order to onboard my application, what you can do is, as the manager for HashiTalks namespace, you can say, let's say, for example, instead of a PKI role, I'll just do a application modules. I want to add I basically want to add an application. So I add the module to my code, and I say my module is, let's say, 3-tiered web internet banking. This is my application. Now, what Terraform will do is to give you this code, and let's say as the namespace manager or admin for HashiTalks, you can then commit this code, add a little file, new application. Let's give this module a proper name. All right, so once the module is committed, the code is committed, you will be able to see, all right, the newly created workspace will pick up that change. Remember, this is your pipeline. Terraform is your pipeline. It'll pick up the change from the repository and do a plan and apply. Within a few minutes, let's say, you should have a relatively good stuff. So you have all the policies added. You have your internet banking with different stages, with staging or testing whatsoever. And after that, it will go through a policy check. Let's wait 20 seconds more. All right, the policy check passed. So we can see, obviously, because we're giving a whole pipeline to the users, we actually want to control what they can do. So in this case, I have limited the number of providers, the kind of providers you could use, and the kind of resources you can provision. And then I restricted that you can only use the private module from this organization and nothing else. By doing these policies, the Vault admin can be assured that no matter what code gets provisioned or gets committed into this repo, if it doesn't comply with these 3 policies, it wouldn't go through. Now, in this case, we passed everything. So we just apply. Then the application will be onboarded. Now let's look at the Vault. Inside Vault, let's say HashiCorp. Let's do a refresh. Oops. In HashiTalks. Let's still use that Vault token. I don't think you can. Okay, now you can see that the applications has been onboarded with different environments. You can then start writing your secrets into the secret engines. That's basically the way to onboard application. Now, if we go back, looking at having a review of what we've demoed. What we've demoed is basically managing Vault at scale using the top level logical separation namespace, and next level is application, to basically do the policy, the authorization policy segregation. On top of that, this is just on the Vault side. On top of that, we build a repository. We build the pipeline that we build a repository that stores the code, Terraform code for that given namespace. We've built a pipeline, which is a Terraform workspace, to securely apply any change so that you don't have to manual review. And then in the pipe, as part of the pipeline, we have some policies to govern what you can provision and what you cannot provision. So the end result really is fairly clear. I guess instead of you fighting your computers, as that busy angry cat is doing, you can now relax and listen to music. That's the conclusion of my demo, my session. I do have some code that I'm going to make this available as public repos, so that you can use. That's all from me. Thank you.
So first of all, thank you so much. That is a very nice journey, and just the idea of combining Vault and GitHub and Terraform. I'm a huge fan of the GitHub provider, and using it this way. It's just, getting secrets from left to right without going insane with all the pipelines and all the various steps is just amazing. You had a ton of really good links on there. If you can send them to me via Slack, we'll get them shared with our audience as well. Or even that, I'm just going to take a screenshot for that because this is good stuff.
No worries. Thank you.
And it works. It's a code like this that helps people to get up and running quicker. And Taylor and I, we like to joke that, the goal is always to get people to hit the ground running rather than just to hit the ground. And I think the patterns you have in here are definitely that. So that's a good one.
Thank you, Karim.
Lucky.
Yeah, any way you can get people dangerous with code straight away is a huge benefit, I reckon.
Cool. So I'm going to make this all these repositories public in about a day.
Fantastic.
Cool. This is like a nice start into the weekend. It's like, I saw this at HashiTalks. I want to try this out. Oh, hey, here's some sample code to start myself off with. That to me is like you said, it's the best start of the day. Very, very cool.
Oh, thank you.
Yeah, my weekend's a write-off now. I'm going to be digging into Vault namespaces and going and making my own little lab for it, which is awesome. So thank you, Yuli. That's awesome.
No worries.
Awesome. Well, we get set up for our next speaker. If you're new to one of our products, we have a learn set on learn.hashicorp.com where we have tutorials around all of this tooling. Also, I love the cat picture, just random call out. It was such a good one.
I spend most of my effort on the slide on finding these two pictures.
It was time well spent. I'll tell you that.
I agree.
So these are classics. It's a very beautiful cat. I feel like like anytime you bring pet pictures into a tech talk, it's going to be a good talk. It just is. So as I was saying, if you are new to our technologies, if you are curious about learning Terraform and Vault and any of our other products, we have amazing tutorials on our Learn side. And I say that they're amazing because I know the people who work on them really take care of updating them, making sure, whenever we have a new version, you get something that's very up to date. And we try to solve the problems that you might encounter and teach you good patterns. That being said, if there's tutorials that you don't find but would like to see, find us on Twitter, send us an email, and we'll see what we can do. Definitely need to have something on GitHub on there because, GitHub provider is just so amazing when you get used to it and figure out how to do things with it.
especially when you can, you can create those templated versions and then you can nest all those things together. It makes life so much easier for people that are just trying to get started on, maybe if it's Terraform or building modules or using Vault namespace, you can literally go, okay, here's how you go and accelerate. It just makes that super easy.
It really is. It's also, like that fear, every time you do secrets management, people already go like, okay, this is hard, this is difficult. And I think one of the earlier slides that you had showing essentially the secrets management architecture, not how to run Vault, which on its own, can be difficult, and running it at scale can be difficult, but just like, how do I think about what is the path for my secrets? How do I account for future changes? It's, there was some really good learnings in here. So thank you again for sharing.
Thank you.
And with that, I think we have our next speaker here. David is here. So thank you again, Yule.
Thanks.
And there we go. Good day, David. I'm still not there. Am I lucky?
You're still not where, sorry?
I'm still not there, right? With the pronunciation of that.
The g'day, look, it's getting better. We'll keep working on it backstage, I think. I think you just really got to lean into it. I'm keen to hear David's g'day though as well. I reckon he might have a good one.
You might be muted there.
Yeah, can't quite mute on that, David.
A quiet one.
But there was a lot of effort. I saw the gusto behind the effort and I appreciated that. I think there was a lot of effort on the g'day.
That also works. While we figure out some tech troubles, which, is part of the HashiTalks brand. We, if there were a Terraform provider for this, life would probably be easier. Though I don't know how we could make that work, but
well, after the first speech from Jesse, we could run it all through CSV. We could run the live stream from CSVs.
This is true. Yeah, we may have tried something like that for one of our Christmas holiday hackathons, pulling data from Google Docs into Terraform and then pushing it into console. If that sounds offensive to you, that's totally okay, because it was.
Yeah, I bet that worked like a dream.
Yeah, it was. There's definitely nothing wrong with using Google spreadsheets, so Excel essentially, as a KV store. Nothing at all.
Perfect.
The queries there are just amazing. David, how's your mic doing?
Still haven't got him.
I'm gonna say, let's see. Just gonna mute you and unmute you. There we go. See, I see the lips moving. Yeah, your Zoom might be set to a different one. And if you're watching this at home, you might be wondering, like, don't they test this? And we did. We just had a backstage mic check. But if you've ever worked in infrastructure, you know that whatever you put into your code and into your test is not what happens in production.
Yeah, that's it. Why don't we, Karim, we'll swap to the speaker stream. We'll try to work with David and sort out the volume issues that he's got going on. See if we can get the mic working. So I hang around for about a minute or two whilst we try and get David's mic up and running on the Zoom call. But enjoy some really cool music that Taylor, one of the producers on this one, has put together for us.
me now?
Yes.
All right. Okay. Cool. Yeah.
Thank you so much for troubleshooting this with us. I was gonna kick off by saying congrats on being, hitting your 3-year mark. Beautiful. I mean, that's what LinkedIn tells me.
Yes. It's actually tomorrow. Tomorrow's the day.
Even better.
Thank you.
Well, now that I'm hearing David's voice, I'm not sure about the strength of the g'day though. I don't know if he's going to be able to top your career, but I'm still willing to give it a go, David. If you're willing to give it a go.
No, I'm not. I'm incredibly Irish.
Fair enough. Fair call. I wanted to hear the Irish g'day, but I respect that. Fair enough.
Yeah, I mean, it's almost too good that it becomes offensive.
Yeah. Okay.
I
thank you for thinking of me for that. Thank you. I appreciate that.
Yeah.
Don't actually have an opportunity to learn this.
Yeah, it's hard to do it without swearing.
Oh, so when you said you were having tea as prep, okay, I see. Yeah, so it wasn't tea. Got it. Noted.
Yeah, no, it's DB.
Yes,
Awesome.
David, I like that. I'm really pumped for this talk, though. I think there's a lot of value in extending beyond the traditional thinking of infrastructure and then into like how do we think about that infrastructure and keep it up and the ongoing operations of those things. So I'm super pumped about this one.
Yeah, absolutely.
Yeah, I was just saying that because of things like poor network availability, I might have taken about 5 minutes off or 10 minutes off the talk, so it might only be about 20 minutes.
That's why we insert random technical troubles to still make up for the schedule,
Yeah,
it's all
punctuality
good.
is important.
Yeah,
that's
it. That's the only reason. It's whenever you're ready to start your share, hit it, and the stage is yours.
All right. Let's go. Okay. Hey folks. So sorry for the somewhat minor technical delays. Yeah, so I'm David Ridge. I am senior solutions consultant at PagerDuty. And as such, I get to talk to a lot of different organizations, different customers and potential customers all over Australia, New Zealand, and Southeast Asia. And I really get to understand a lot of the problems that those organizations are having. When it comes to operations, there's kind of a fundamental shift that's happening all around the world, really. And it is moving towards a more kind of a service ownership, more of an agile DevOps SRE kind of way of working. And for a lot of newer born in the cloud organizations, that is a great way of working. It requires or it allows for great flexibility. But for larger organizations where there's a lot of existing process and existing infrastructure in place, a lot of on-premise stuff, it leads to sort of a hybrid environment whereby they want to do newer, more flexible, agile things, but there is still a lot of legacy systems going on. So when we talk about automating operations, we sort of have to take into account both methods, both ways of working. And so I guess one of the things I wanted to talk about today is how do we look at operations holistically, and how do we allow for this level of scalability, this level of flexibility, being able to use configuration as code, being able to use all the tools that are there, in the marketplace these days, while also maintaining the things like compliance, regulation, having to raise tickets and things like that. So first, when we want to talk about automating operations, let's first look at the historical scope of operations where, if we're going into organizations that, larger banks or insurance places or telcos and things that have been around for decades, you traditionally have this kind of a model whereby there was an application that was sitting on some infrastructure. You might have had some monitoring for that, or maybe you didn't, and you just had people who called in saying that it didn't work. that raised a ticket, and then there was a very structured, centralized way of dealing with that ticket, whereby the level 1 people decided whether it was an issue or not. If it was, they brought it to the level 2 people who tried to restart the box, and if it turns out that the problem was inside the box, then it went to level 3, who are the people who knew what was inside the box. That still exists a lot to this day, and there's still that kind of linear, centralized way of working. But as we kind of all know and love, there is, operations has moved forward considerably. The modern scope of operations is one of what we call these Death Star architecture diagrams, whereby you have hundreds and hundreds of microservices owned by hundreds of engineers and developers, all weaving dependencies all over various different aspects of things. And so, combining this with a level of service ownership, of a kind of build it, run it mentality, means that not only do you have like distributed applications and networks, you also have distributed ownership of, basically the uptime and operation of the overarching technology. For example, Netflix is entirely dependent on its uptime. If Netflix is down, there is no Netflix, which used to be the case, I guess for those older millennials like myself, who remember Netflix as a DVD company. But, it's now entirely based on uptime, right? And so that decentralized ownership of that uptime is something that requires a fair bit of complexity and trust and organization in order to ensure that it runs smoothly. So how does PagerDuty help? Well, I guess for those who are unaware or who have never heard of PagerDuty before, in short, I guess PagerDuty is a platform for real-time operations. It enables everyone across your business to manage urgent and mission-critical unplanned work. And when I say unplanned work, it's such as the kind of events and alerts and incidents that are generally generated by these kind of tools, right? Whether it is, your classic IT operations, let's raise a ticket because something has happened, whether it's more proactive in the kind of monitoring and observability world of your APM tools, etc. Whether it's coming directly from the cloud infrastructure that you have, or the cloud products that you have, or even now with the cloud monitoring tools, the cloud native monitoring tools that are there, or whether it's actually, and which we're seeing more and more of from the CI/CD pipeline, right? Where, for example, Netflix, who are a PagerDuty customer, staging has become as urgent as a production issue. Production issues are basically something has severely gone wrong. If we're catching things in production, we should always catch them in staging. And so therefore there is real-time response required for not just production environments, but maybe all the way down through. So, the classic kind of flow of information coming from these monitoring tools and from these IT operations tools can come into PagerDuty. And then as a result, when we talk about operations, there is this entire flow of exactly what happens, not just about, understanding what is broken, but the actual process of then responding to that particular issue. At a very high level, to talk just about PagerDuty quickly, to put it in context, we can consume all the signals from those various different monitoring tools, those events, those alerts, incidents, etc. And they don't always have to be bad things. They can be actually opportunities, right? There are a number of different use cases whereby, there's a spike in sales, or we need to reroute marketing here and there. But being able to just understand, while those monitoring tools will hold the logic about whether something is wrong or not, PagerDuty can understand the context of that and really control, what do you want to do about that? Right. So yes, CPU has gone over a certain limit. Well, do you need to be called in the middle of the night? Well, it depends, right? It depends on a number of different things. It depends on, well, what service is it? What application are we talking about? What piece of infrastructure are we talking about? What environment is it? What time is it, right? Like if it's during the day, then no, because we're all online. But maybe if it's 2 a.m., then yes, I do need a phone call. So being able to understand that context. Or do I need to raise a human at all, right? Machine automation, maybe, why can't we just resolve it ourselves? Can we not just, increase auto scaling, or just, destroy the instance and create a new one? Or maybe it's a combination of both. Maybe it's, we'll try and automate it, and if that didn't work, then we'll escalate it to a human. So being able to control what you want to do about the fact that, you're getting these alarms, these metrics and alerts, is kind of at the core of what PagerDuty does. Now, when we talk about automating a lot of that, it introduces some level of complexity, but also it introduces quite a lot of opportunity. Because if you take the kind of capabilities that are behind that diagram, we talk about, ingestion. We're going to, the practical nature of that is that we're going to have to try and consume all the different signals. So how are we going to get information from, let's say, CloudWatch into PagerDuty? Oftentimes that's by API, sometimes it's by email, depending on maybe if it's not CloudWatch, maybe it's some on-premise system like SCOM or Nagios or something like that. And then we have to understand, well, what does this signal represent? Who should it go to? And then what about that person? So what's their phone number? What's their mobile app? What's their email address? What's their schedule? How often do they work? Who are their teammates? And being able to understand a lot of that, as well as being able to scale that, right? And then, okay, so we have all the stuff that happens before the phone call, which is, who should this go to? Have we already raised an incident for this? And so we can correlate things together like that. Maybe we should suppress it because it's something that we don't really care about. Maybe it's just a warning. Maybe we'll wait and see if it automatically resolves itself before we raise an incident. Maybe we need to raise an incident in ServiceNow. Let's spin up a Jira ticket or something before we ever actually notify a person. And let's track everything that happens. So there's a lot of individual components and considerations when we do that. And they can be different from team to team. So as we mentioned, if we're decentralizing a lot of this, if we're pushing the ownership out to the teams who are building it, who are now designed to run it, you can have a lot of variance. Certain teams may only care about high profile things, or they only want P1s and P2s, or when the thing is on fire. Other teams may want to be alerted for not necessarily incidents, but like downward facing trends. So they want to be able to catch something before it ever becomes an incident, which obviously happens a lot more than actual incidents. And so therefore they need a way to understand the noise, right? And then, okay, so we have all that stuff that happens before the incident. We have notifying the right person. Then we have a bunch of stuff that happens once that right person is awake, right? So whether that's mobilizing multiple people, whether that's being able to automatically remediate, being able to track all of that that's going on. So a lot of configuration, very dependent, and also can be quite varying depending on the different services. And that's a lot of the reasons why we will see pushback on a lot of newer ways of working from larger enterprises, because they don't want to let go of that control, because they're afraid that something like a P1 would be missed, because it's the developers or whoever who are in control of that, and they don't know what to do. So how do we overcome that? We overcome that by creating standard patterns. We overcome that by creating templates, and we overcome that by automating the configuration to achieve like a baseline, right, that everyone can agree on. And so let me take you through a quick example. In this is kind of a pretty linear example. So maybe taking one of those 500 microservices out of the Netflix or the Twitter Death Star, and let's kind of just open it out for a second. What we have is maybe an application or some kind of payment processor that's deployed on an EC2 instance. And then we have Phil. So Phil is our engineer, right? And so Phil is the person who wants to know, he's on call right now, and he wants to know when, or he's responsible for the payment processor. And so he wants to know when there are certain alarms that go wrong with the payment processor or the EC2 instance that are on it. So what Phil needs to do is he needs to create some of these alarms and make sure that they are currently monitoring the particular instance And when any of these happen, he wants to know. So what he'll need to do is also configure a service. Now in PagerDuty, the service is basically the thing that you're having the incident on. It's the thing that you're monitoring. It basically represents the payment processor and that entire stack that Phil is responsible for. Once that incident actually happens, or once that service is created, he wants it to go to his team, his escalation policies. So this is an object inside PagerDuty that we talk about. And the escalation policy is basically the payments team, the way in which it's almost like the contract of engagement. It's the way in which they want to be notified. So Phil is the primary on-call person. After 5 minutes, if he doesn't acknowledge the incident, it's going to go to the secondary responder. And then after 15 minutes, it's going to go to the manager. This is kind of a standard best practice escalation that we have set out in PagerDuty. Now, if we had to do this for every single microservice, there could be a lot of variance and a lot of inconsistencies, I guess, in the process. But because we can do all of this inside Terraform, it allows for an entire kind of end-to-end process of every time that we deploy something new, every time we release something, every time we deploy an EC2 instance that has something on it, what we can do is we can define basic standards, whether that is we must always have at least 2 alarms on every piece of infrastructure. It might be we also have to have some New Relic alarms that are running synthetics through the payment processor, right? So of these 5 or 6 standard things, if you use our pipeline, if you use our platform, then you will, we can guarantee that you're always monitoring these kind of 5 key metrics for any net new piece of infrastructure. We also can then set up standard structures, which means that it's not just going to go to a group email, or it's not just going to go to a Slack channel. There are genuinely people who are on call who are going to get notified about their specific things, and we're going to have backups and triages, right? Similarly, there's a whole bunch of other capabilities that can be automated on deployment so that we can kind of copper fasten the operations around it. This gives, number one, it gives Phil and his team a platform for ensuring that they know exactly what's going on with their own services. Number two, for kind of larger scale organizations, it gives a sense of assurance for their ability to understand at least what's going on and be able to enforce patterns and things like that. Of course, if we look into the code of this, it's kind of just your standard Terraform code, right? So we have PagerDuty has its own provider, and so when we talk about provisioning the particular instance and provisioning the alarms, we have a particular CPU alarm here, pretty aggressive, but it has a particular action of an SNS topic. That SNS topic has a subscription that will send the alarm directly to PagerDuty. And you'll see here that PagerDuty has a CloudWatch integration key. So if we pop over onto the other side to the payment processor, we'll talk about the PagerDuty service. We can define that as code, right? So every net new application can also have a corresponding service inside PagerDuty. You have this CloudWatch integration that is assigned to that particular service for the payment processor. And so when we create this integration, that will give us the integration key that will provide back to CloudWatch. Once we raise an incident on the service, then we have an escalation policy that is that particular team. So we don't have to create a new escalation policy every time. We can have the same escalation policy, the same group of people responsible for multiple services. And that gives huge amounts of granularity, visibility, and control to the engineers themselves, that they can say, for payment processors, yes, I want really aggressive monitoring. I want really aggressive alarms because that's how we make money. But for maybe other systems that are a bit more flaky or a bit less urgent, maybe I want a different level of response. So you have this really interesting and powerful way of controlling the different ways in which you respond to things, but you can do it as code. Having that end-to-end piece, just being able to have it all in that single kind of pipeline, number one, is very powerful for provisioning. But of course, when we talk about having to make updates to particular things, having that audit trail, having that ability to be able to make decisions, track people's changes, because of course, when we're talking about, finding out if something is if something is down or something has a P1, we really want to even for compliance reasons, we have to be able to understand, who changed what, why that didn't work, for both post-mortem reasons as well as kind of, self-improvement. So if we wanted to maybe change a particular time, or even, make technology decisions like, we're not going to use New Relic anymore. Maybe we're going to use a different tool, or maybe we're going to just use CloudWatch, or maybe now the kind of DevOps guru internally, or, these kind of strategic decisions can be incredibly easily configured, and as such, just create a new version of our monitoring suite. We can go back to the old one if we need to. We can kind of show how we've improved, as well as control the various different aspects of it. So being able to automate this end-to-end operation from provision all the way through to provisioning alarms, and then the thing that captures those alarms and how that actually gets directly to the person, is quite a powerful solution. PagerDuty is quite good at this because, frankly, we API everything. We're kind of an API first type organization, whereby, if we're building a capability, we'll ensure that there is an API there for it. These are just kind of a nice selection of the APIs that we have across various different aspects. And if we look at the Terraform coverage of a lot of that, it is substantial. A lot of the ones that aren't covered there are actually things like, being able to edit and update an incident, looking at people's abilities of a particular user, being able to pull analytics or who's on call, as well as, being able to just send events directly to PagerDuty. There's one in particular that I want to touch on very quickly that kind of elevates this quite further. Now, you saw in that last example, it was quite linear. It's like we have a single service, we have a single team. But the reality of things is, as we saw, service dependencies is one of those things that is becoming quite evident. It's extremely evident when you look at all the different lines between this thing, right? And fundamentally, one of the problems that PagerDuty is often tasked to solve, and one of the best ones, is the problem statement from a developer or an engineer or somebody who's on call, who says, I want you to tell me if my application is down or having issues, but I also want to I want you to tell me that it's not my fault. I want you to tell me if it's the guy upstream from me, or if it's a multiple event, and not have me, have to diagnose for 20 minutes to understand that it's actually not my thing. And so being able to understand the context and service dependencies, of course, we can do that in code, whereby that service that we talked about, that payment processor service, we can define various different things, right? So whether there are downstream, all of these different various processors and load balancers and things roll into a larger online payments business group, but also that it has a supporting service. So it sits on the API platform. And so if the API platform is having an issue, that's something that I probably need to know, because I'm in charge of one of those APIs. How that actually represents when you configure it like that inside PagerDuty, it's kind of like this, basically. So we have our payment processor that I'm currently on call for, that Beth is currently on call for here. And we can have a visualization that, yes, while we're having our incident going on, there's also something upstream from us that's having a particular incident, right? You can get that kind of visualization. And this is, a decentralized model. So this is just for me and my team. And so we can configure that directly to how we want it. Similarly, when we're actually during an incident, we can have the concept of technical service dependency. So while, yes, you are having an incident, you should probably know that the thing upstream from you is also having an incident. It can't connect to host, as well as, there are related incidents going on. So not only are you in the payment processor API, but also the login API and the shopping cart API are also having very similar issues. So maybe it's not your fault. With PagerDuty, being able to configure as code on deployment, how all of these applications, how all these microservices or whatever they might be are linked together, gives responders huge amount of context. It gives them instant context so that they don't have to waste time, going down a dead end. And it also provides a lot of value to the wider organization, because at least they know that you are implementing their standards. Last thing I just want to touch on is the PagerDuty provider. So myself and a number of my colleagues at PagerDuty, we are active contributors to the PagerDuty provider. So every time something new gets released, it is starting to become a requirement for release that, do we have the PagerDuty, do we have the provider in place? Are we adding this to the provider in the near term, etc.? So we are keeping it very much up to date. So it has a lot of the cooler stuff in it. And just, I guess to just reinforce some of the reasons why we can look beyond just infrastructure as code and provisioning things into provisioning the support around those things, right? You can manage that configuration at scale. It means that you don't have to go back around and remember and try and figure out what you have coverage for and what you don't. And so it can also enforce those reviews and permissions to ensure that you have that high quality and those best practices. It can also ensure that you have compliance for new features, right? So any new thing that gets released on this platform is automatically compliant, and you don't have to worry about it because you inherited a lot of that stuff. And it allows you to provision complex interdependent environments. That's pretty much all I have for from a PagerDuty perspective. Please check us out if you want to know more about PagerDuty, or you just want to know more about the how you can configure Terraform using PagerDuty and in your ecosystem. Please hit me up or reach out to anyone in PagerDuty. Thanks very much.
This was amazing. First of all, to answer your question, do you need to be called in the middle of the night? I'm going to go with need, maybe want to, definitely not. I want infrastructure that works, which I know we're all striving for. It never happens that way. As we've seen from Zoom this morning and afternoon and everything. One thing that I really, really enjoy, and this is completely, well, it's not completely off topic, but it's a little bit special to me. It's you're talking about the Terraform provider for PagerDuty, and I want to just give a special shout out to Alexander Hellbaum, who built the initial version of this and who also was a speaker at the first version of HashiTalks DACH. So it feels like, like the rotation is now complete. We have achieved that beauty.
I've met Alexander. We invited him to San Francisco at our event. He got up on stage and spoke, and that was kind of the handing over of that provider from him, who, like, absolute legend. And when we decided to bring it in house, yeah, great guy and incredibly talented.
Yeah, absolutely. It's nice how small our community really is, despite being actually spread out across the globe and having everyone here. I think, like you mentioned this earlier, taking Terraform out of the standard context of I can do virtual machines on a cloud and bringing it into the non-standard things and codifying those, it's such a force multiplier, I think. Like, yeah, I mean, codifying your culture. Sorry, go ahead.
I was just going to say that, to me, the strength of Terraform is that, it can be multi-cloud or single cloud, but it's multi-platform. It's the game-changing way of changing the way of working that I think that stretches across multiple facets of your platform or infrastructure or all of those other different components that gives it that strength. And I think that the ability to do that and extend is what makes it such a powerful tool to be able to use, be it, from Yuli's speech, we went through the GitHub and how we can do that to now how we can do the AI ops side of it with PagerDuty providers. And we've got Vault and Terraform and all these other bits and pieces we can configure, even with Terraform itself, being it Terraform Enterprise or Vault Enterprise. You can kind of, you can kind of even, order a pizza with it. So you can do everything with it. And have to get the Domino's provider in somewhere and a HashiTalks event. Can't not make it a mention. It would be irresponsible. But I did have a question for you, David. Actually, I was wondering, what have you seen as the biggest kind of positive change that being able to codify the PagerDuty setup with something like Terraform has actually had on the kind of the use of the product? Has it made or brought, let's say, that traditional IT operational side, into the fold of that DevOps capability more?
It has. It's definitely brought a level of trust, right? Because people understand the, traditional IT operations people don't, well, maybe some of them, but they understand that peer reviews, pull requests, auditability of what's happening works for their applications, right? They work for their internal applications, and they trust their developers in the process for that, but they don't trust it for making sure that they'll answer an email. It also helps with so to finish that point, so including the configurability of everything after the code, right? So the response, the signaling, all that kind of stuff, it becomes tangible, it becomes reviewable, it becomes auditable. And so therefore the powers that be are a lot more comfortable in having a decentralized operations, which is, the key to that trust is really the key to the DevOps SRE agile way of working, right?
Yeah, absolutely.
And then the second part of that is around being able to, there's always that concept of like just another tool, right? So there's a lot of clicking involved. Do we need another thing, another interface, another screen that they have to go to in order to do a thing, right? And so you can get tool fatigue. But the fact that you have this kind of single interface, even though it's code, right? Even though it's like Visual Studio, whatever it might be, it's a single interface that you can manage multiple technologies, right? And I think that's, to me, that's one of the key strengths of Terraform. While PagerDuty, we call ourselves like the integration hub, which we very much are, because we can make it really easy, for example, to raise a ServiceNow ticket, regardless of if the thing comes from CloudWatch, New Relic, or PRTG, or some email, right? All of those things can go in kind of a single pipe. But if you wanted to configure that, you would generally have to go into CloudWatch and then into PagerDuty and then into ServiceNow, et cetera, et cetera. Being able to codify that just removes all the clicking. It removes all the various different screens, and it allows you to properly unify the application all the way through to the ownership of that application. I think that's very powerful too.
I think it's the unspoken benefit a lot of the time is that that single way of working now shared across multiple teams, and how that now enables kind of a shared level of understanding and communication across a standard problem set. Previously, if that was, I've got my .NET app and it's in Kubernetes and it's on cloud and it's on-prem, okay, there's 3 teams. Oh, now I want to monitor that. Okay, well, then there's the monitoring. Now how I want to alert on that, well, then there's the ITIL or the traditional operations team, right? And so now we're able to span all of those things with this constant and a constant level of communication where everyone's attempting to solve those problems in the same way. I think that's super powerful, and having products like PagerDuty where you can kind of use that as some of the glue to solve that as well from that capability is super important and can really provide a lot of value. So awesome talk. I really enjoyed it and learned a lot.
Yeah, absolutely. It's so many good points that you're making, like the auditability of your platform and being able to codify essentially culture aspects, right? Like, how do we deal with this, and how do we make sure our people feel comfortable, answering that page, and how do we make sure it ends up at the right person, the level 1 versus level 3 debate, and where you're going after that. It's yes, definitely good. I loved it. With that, thank you so much. We'll have our next speaker up, and I'm excited for this one, because we have another HashiCorp ambassador. And if you're not familiar with the program, it's essentially our recognition program for members of our community who contribute blog posts, knowledge, their time, generally, mentorship in the broadest sense of the word. Like Lucky, for example.
That's me.
I'm excited that over the past year, we grew, I think, from 50-ish to 80-ish people, and just seeing the output, not in terms of metrics, but the in terms of what people actually do with the tools is just, it's just mind blowing. I'm very much enjoying it.
It's great to be a part of the program, and you get to meet so many like-minded individuals trying to solve problems, as we were talking to David, with this single kind of tool and way across the Hashi stack, and getting that kind of a way of working, silo almost across the entire stack of technologies together. And Bruce is one of the key people, especially in the APAC region, about doing that. Even though he's over in kind of Perth, we won't hold that against him. It's okay. It's all right. But we want, we make fun of him, but that's all right. But he brings a wealth of knowledge. He does a lot within the SRE space himself. Works at a place called VGW, which do some really awesome and interesting things with technology and solve some interesting problems. So I'm really looking forward anytime to when Bruce is talking, but especially today, because he's talking about automating snowflakes, which I'm very keen about, because I've had a play with the provider here on the down low, and I'm pretty interested to see what he's been able to wrangle with this one. It should be pretty interesting.
I'm definitely curious. I'm actually curious while we're talking about snowflakes. I mean, it seems to be 25 degrees in Perth right now. So yeah, there can't be any.
It's about as cold as it gets in Perth.
Yeah. All right. Whenever we're ready, let's switch.
Hi, in this talk, Automating Snowflakes, I will walk through how we leveraged Terraform's declarative language and provider extensibility within our CI/CD pipeline to create Snowflake and AWS resources that continuously ingest data from S3. My name is Bruce, and I'm the squad lead for reliability and quality at VGW for a product called Global Poker. I'm fortunate enough to work with some amazing teams and help improve our product stability and reliability using Ollie, automation, and incident response. I'm also a 2020 and 2021 HashiCorp ambassador. Okay, let's do a bit of backstory. Why do we want to automate snowflakes? What is a snowflake? And what problems were we trying to solve? Last year, we kicked off a project to get better internal visibility of our data to help us and the business make better decisions. The business already had existing data flowing into Redshift where it would be aggregated, transformed, and visualized in using other tools. This was useful. However, the operational team did not have easy access to Redshift and could often be delayed by 24 hours. We wanted real-time visibility, or close to it, of some of our data in fast and a cost-effective way without the need to rely on other teams to provide it for us. So we selected the use of Snowflake to house, transform, and query our data. If you're not familiar with Snowflake, it's a cloud compute-based data warehousing company, and they provide a fully managed storage with scalable on-demand compute instances for super fast query of your data. Snowflake would enable our teams to get answers almost instantaneously for our data. We had the technology, so now we needed to build it. To get our data into Snowflake, we would use process managers that would read data from our database and would use Kinesis Firehose to land that data into S3. From the S3 bucket, we would use Snowflake integrations and Snowpipe to pull the data into Snowflake databases. Then we could use the Snowflake's lightning quick transformations and queries with their compute resources. For the sake of the talk, I'm going to focus on the landing zone, which is the S3 bucket and the Snowflake integrations. As you can see, this architecture requires infrastructure to be provisioned in both AWS and Snowflake. To set this up, we needed to configure access permissions for the S3 bucket. We needed to create IAM roles in AWS, create a cloud storage integration in Snowflake, and then go and retrieve the AWS IAM user from Snowflake account, and then grant that IAM user permissions to the access bucket in AWS, and then finally create the external stage. As you can see, there's a lot of steps, which involves going in and out of AWS and Snowflake consoles to create a single integration. Who wants to do that? Hopefully no one. We had several options to choose from when provisioning our infrastructure required for the solution. Option 1, we could manually click ops the creation of the resources in AWS and Snowflake. No thanks. It's not very repeatable. It's error prone and requires elevated permissions to do so. Another option, option 2, we could automate the AWS components in Terraform and output that information required for Snowflake to consume, and also create a SQL script or flyaway script that would run to provision the Snowflake components. But we still had the dance between Terraform and Snowflake, and we still have to update the scripts on the fly to get the final results. Doesn't sound very declarative, does it? Our final option, option 3, we could use Terraform to provision all the resources using Snowflake and the AWS provider. This way we could pass outputs from an AWS resource to Snowflake resources and declaratively provision our required infrastructure. Better yet, we could write reusable modules that could be used again and again as we landed more data into S3 buckets. I think that's the winner. With the extensibility of Terraform, we were able to use multiple Terraform provider plugins to manage different types of provider resources in the same Terraform config.
Bruce gets it.
For our purposes, we use both the AWS provider, which most people are familiar with, and the Snowflake provider created by Chan Zuckerberg. Hopefully I'm saying that right. To use more than one provider in the Terraform code, it's easy as adding the Terraform code or Terraform configuration, as you can see here. So you've got the Snowflake and AWS resources, the source and the versions.
One of the worst things about Microsoft Teams is that
now we have our provider added, we need to configure our access to the different providers by passing the required credentials. The safest way to do this is pass them in as environment variables. We do this by setting our environment variables in Terraform Cloud. That gets exposed to the shell environment as it's being run in Terraform Cloud. Plus it's encrypted. What's next? Well, first, we need an S3 bucket. This will catch all the events from our process manager. So we add an S3 resource to our config and also need to make sure that we block public access. Access to the bucket will be tightly controlled by an IAM role, which the process manager and Snowflake will have access to. Then we create a Snowflake database with schemas, graphs, using resources from our Snowflake provider. Now this is a very simplified graph structure. As you can see, you'll probably need to add more graphs to it, like usage, update, and select table on views. Please don't take this as the gospel for this one. Then we create an S3 integration for our Snowflake to be able to connect and pull that data. In this case, we write a reusable module that creates an IAM role that has access to the S3 bucket and adds the Snowflake ARN and external ID, creates a Snowflake storage integration that references the AWS role ARN, creates a Snowflake S3 storage stage that connects to an S3 bucket, then creates a S3 bucket notification to poke Snowflake via SQS, and creates a Snowflake pipe that is notified by the SQS for any changes that happen in the bucket and copies that data into the target database. This does sound a lot, but by using a module, we can use this code again and again, and also reduces the lines of code you have to write again and again as well. Okay, demo time. Okay, we're going to jump straight into the demo. So here in our main.tf, in our Terraform block, we're actually telling Terraform which providers we want to use. So the source and versions, which version of that Terraform provider we want. We want Snowflake and the AWS provider. We also have our remote backend set up. So this is the Terraform Cloud account I have, and my organization and the workspace that it's going to be connected to. Underneath that, we've got our actual provider configuration. So here we've got the regions set in both the AWS and Snowflake providers. All of the secret credentials are stored as environment variables in my Terraform Cloud account, so way safer and encrypted. So we're going to kick off with a database first off, the Snowflake Hello World database. Now I'm using a module here because it's far easier for me, because if we go jump into our modules and my main for my databases, there's quite a bit that needs to be created. So we've got the database, but as well as the grants for the database and table and schemas as well. So I'm using a module for that. Then we're going to create a table. So this is where we're going to land our data connected to our database and schema created from this module here. And we've got our columns here, which is going to house our data once we've landed it. Then underneath there, we have our S3 integration module. So it looks quite chunky, but all we're doing there is just creating the IAM roles, telling it which S3 bucket to use, the storage path, the database and schema, and the copy statement. If we jump into our modules under S3 integration, we can actually see what it's actually creating here. So we've got an IAM policy that's creating, that's going to allow us to, or that role to create, so connect to that S3 bucket. And we've got some roles here that's connecting to the Snowflake storage integration and the user from that, and the external ID provided by Snowflake. We've got our integration here that we're creating, so Snowflake storage integration and our grants. We also have our Snowpipe as well, so that's going to be looking for our changes within our S3 bucket and then pulling that across. We have our staging, which is what's connecting to our S3 bucket from Snowflake. And then that's it. So what we're going to do now, let's kick that off and create these resources. So we're going to Terraform apply. And I'm using Terraform 0.15 at the moment. Thought I'd give it a go since it's nearly out. So far, so good. So what this is doing now is creating or connecting to my Terraform workspace in Terraform Cloud. Is kicking off a Terraform run or an apply run. As you can see here, it's telling me what is going to create. It's quite a lot, 21, 22 resources. Okay, we're all good. Yeah, here we go, 21 resources. I'm going to just manually type in yes if we're doing it as part of a CI/CD pipeline. This would be done by an API. So entering yes, and that's going to confirm that on Terraform Cloud and that workspace, and kick off the apply. Oof, there we go. Creating databases, grants, roles. all the stages it needs to connect to S3 and Snowflake. And we're done. Okay, what we'll do next is jump into our worksheet in Snowflake. So here we are in our console for Snowflake. I've signed up for a free account. It's super easy to do that, so you can have a play. If we refresh our database objects here, we should see Hello World come up, which it does, fantastic. And we can click on that, and here are curated public and raw schemas that we also created, and hopefully alongside our Hello World table, fantastic. Now, there should be nothing in there, obviously, because we haven't moved any data in there yet. So we'll click on select an empty table, fantastic. And we can also see our list, actually our staging, so we can see if it's connected to our S3 bucket. Awesome, there are no files in our S3 bucket. So let's jump into S3 where our data is going to be landed. So this is our bucket, our HashiTalks Dev Snowflake demo bucket in US East 1. We'll click in there, and here's our staging path. So where all of our files will be dropped into. Now let's upload some files in there and just see whether they come across into Snowflake. So we're going to upload, and we're going to grab our example files. We'll grab those and just chuck those into S3. Now we're not going to enable bucket versioning because these won't last very long. This is just for the demo, so we'll click upload, and they're going to, awesome, succeeded, upload. Now I'll quickly want to show you just the properties of that bucket here. So Terraform did create a event notification, so this one here, which is going to notify the SQS queue in Snowflake when anything gets put into this path here. Okay, let's jump back into our console here, so we can actually have a look to see if those buckets, if the bucket is being connected, see whether Snowflake can see those files. We'll do another list on that stage, and we should see those 3 files here. There we go. These are our files. So this tells us that we are connected to our S3 bucket. Then if we're lucky, and the demo gods are playing nice today, we'll do a select start from that table, and we should see data come into those tables. Not just yet. Oh, there we go. A couple of refreshes, and here we go. So we've got the city, state, postcode, sales date, and the price all updated from the data from those files. Awesome. Okay, let's move on. So you can see that from our demo, our integration is up and running. We have our Terraform code that declaratively describes what we want our infrastructure to look like, but now we want some controls in place to only allow approved changes to be applied to the AWS and Snowflake environments. We use GitHub for version control and use GitHub Actions as our CI/CD pipeline. This allows us to kick off planned workflows via Terraform Cloud API on every pull request that will validate it and verify what changes will be made. We can also run GitHub Actions on merge to master to automatically apply these changes to our CI environment or continuous integration environment. And when we create a release candidate, we also kick off a GitHub action to line up and apply in our test and production environment that can be reviewed and approved for deployment. So the pipeline begins to look something like this. The desired state of our Snowflake and AWS infrastructure is described by Terraform in our GitHub repo. Any changes or actions are approved via a pull request. GitHub Actions connected to our Terraform Cloud workspace kicks off a plan and Sentinel policy checks. Test and production applies are stage gated so that we manually check and approve those before releasing. And once approved, Terraform Cloud runs the apply and creates the infrastructure. So with our pipeline now in place, we now have frictionless, repeatable workflows to provision the entire infrastructure required for our data landing zone that will continuously ingest the data into Snowflake. It's easy as adding a new module block to our code and submitting a pull request. Thank you for taking the time to listen to me. My name has, as always, been Bruce Dominguez. You can catch me on an email on brucedominguez@vgw.co, or you can check me out on LinkedIn. This talk has been about automating snowflakes. I hope you enjoyed it.
Always such a pleasure seeing this. And you're already using 0.15. I love it.
It just came out. I'm like, oh, this is dicey. Why not?
Just do it.
I mean, yes.
Just do it. Just ship it, 0.15, just run with it. That's what I say.
What could go wrong? Especially
just run the demo live, 0.15, go.
Yeah, that is partly why I filmed it. It was just,
we have to try it that way. When 0.15 came out, Taylor, my colleague, got pull requests pretty much immediately with like, hey, here's all the updates. Let me know if anything breaks. And then I went off to sleep. We were talking backstage about the snowpipe statement you showed. It just mind blowing. Like, I can't imagine doing that kind of operation via click ops and like manually typing this in, and it just no.
Yeah, there is a lot of back and forth. So some teams will do it, either they'll do part of it and then just script the rest, or just set up like most of it manually and then just set up the Snowflake components after they've set up the integration. But like I've done it so many times and I know how many buckets we're going to be doing, so I didn't want to keep doing that. So if I could do it in one config, then why not? I mean, there was a bit of back and forth with getting it right, like with some delays between providers. So I've used a sleep resource in there for like 10 seconds just to give me a bit of buffer, and that works great.
It doesn't matter how far you go, sleep is always useful somewhere. It doesn't matter how far you go in technology, there is a sleep statement hiding somewhere. But 10 seconds isn't bad. 30 seconds, 45 seconds. Oh, hang on. There's a lot of room in here for something to go wrong. Yeah. But that's awesome. I think that I've actually played with the Snowflake provider a fair bit back when I was in 0.14, which is now like 0.23.5, and it's come a long way itself too. All of those new resources they've added and the ability to now really do that end-to-end integration. Like I'm in Azure land and you're in AWS land, but the ability that now I don't know databases, and I can talk to you about a database piece of technology in a cloud environment that probably is dangerous for me to know without having the knowledge to know it. But is a really amazing way in which we can, solve those problems at that large scale.
Yeah, it's a great technology. The provider has come a long way. So even since we started playing with it and getting it up and running, like I've bumped it quite a few versions to get some new resources. So yeah, it's always changing, which is great.
Yeah,
and that's part of the community as well.
Yeah, I was about to ask about so it's a pretty largely community driven provider at this stage, right? I mean, from the Chance and Zuckerberg Foundation are running and driving it. How have you found working within the open source community for the provider?
Yeah, I mean, there are obviously some constraints. Like you can do pull requests, you can even update the provider if you need to. But it's been great for what we need so far. We've only hit like a couple of road bumps, which we've worked around, and not really an issue. But it's whenever we get a chance to kind of give back, that's a great opportunity for us because it helps us and drives the provider forward.
Yeah, I think that's what's so beautiful about the community, right? And how strong it is. Like, I mean, I think we're almost at like 1,000 providers, which is just, I remember when I rolled a place I used to work at and rolled out TFE from the first company to do that in Australia, there was like 50 and it's only like 18 months later or 3 years later in between there, and there's like 1,000 of them. Like, and the Azure provider itself is about to hit 50 million downloads, and the AWS one's almost at 350 million downloads. So it's the adoption is huge. So to be a part of that community and like a leader in this community like you are, within obviously being an ambassador again, second year in a row.
Congrats.
Love the shirt, by the way. It's fantastic, and the fact that you keep giving back is awesome.
It absolutely is.
Fun.
People like you make our community stronger, and that's what I appreciate, about getting to hang out with all of you all, despite not being able to travel, because some countries haven't figured out how to do, pandemic handling. But that's okay. In the meantime, like you said, 965 providers right now. I had to look it up. Taylor and I, whenever we do presentations, we try to grab the latest numbers, and it's always like 20, 30 providers more, even if like there's a week between, sessions. It's just so amazing. And that's just the ones that are published. Now, for whatever reason, the Domino's pizza provider is not on the registry. And that might be because it's locally restricted, only works in the US. But
we've all got difficulties that we have to face, right? And I think that Bruce, maybe we have to smash our heads together to get a region capable Domino's provider in Australia together to really help drive the word forward. Maybe
I tried adding a VPN resource to it. It didn't really work out the way I was hoping to. There was some resource sprawl. In the meantime, you brought up a very good point talking about, sharing back to the community. And it's when you send in a pull request, and this is a topic that comes up a lot with community office hours and in general interactions. People are like, hey, I want to contribute, but I don't know how. And so if you're watching this and you're wondering, hey, I love Terraform or I hate it, either is totally fine, but I want to add something and I don't know how to code in Go, that's okay. Docs, right? Documentation changes, super easy, Markdown. Make those, start with those.
And super helpful too, though, right? Because if we don't have clear documentation and you understand it, but a new person doesn't, it's great to kind of clarify that.
Exactly that. And it's such a simple change on the surface of it, but you're reaching so many people. Sure, fixing that one outstanding bug that's been open for 3 years, that will get you all the internet points there are. But fixing the documentation, making it easier for somebody else to adopt the tool is possibly worth even more. So if you're wondering, are docs contributions valid? They definitely are. My colleague Tracy talks a lot about getting started in open source and about this very specific thing. We'll share a link to that session in our chat. But in the meantime, this is beautiful. I mean, this is exactly why we invite people like you. Very nice learnings and everything. Yeah, just good. I'm speechless.
Makes me want to go and play with Snowflake again.
It's fun. It's fun.
It's really cool. It is really cool. I'm a big fan of what they've been doing.
Yeah, and it's super easy to sign up for just a free account. If you just want to play it, it does different regions, different providers as well. So AWS, Azure, GCP. So you can pick your poison.
Yeah. And on Karim's point for that, I'm a docs guy. I'm a docs guy. I'm not a Go. No one would ever want to see my Go. It needs to stay with me. No, trust me, Bruce, I'll send you some. It's not pretty, but you know what?
I'll have a look.
I can make a mean note in Markdown to help out, so that's where I'm strong.
Can confirm. Definitely can confirm. Actually on both accounts. And on the topic of code, Bruce, thank you for sharing the repository. We've put that in the chat, but if for whatever reason you can't see the chat, it's on GitHub, user Bruce D VGW. So you can find it there. The HashiTalks Australia New Zealand demo. There is some nice stuff in there, so I definitely recommend checking that out, including very nice readmes, unsurprisingly. Definitely what we want to see, because if you're new to this kind of code, then it helps to have everything really, really well described. So thank you for sharing that.
No problem.
I know people will appreciate this.
Absolutely. Not more than me.
Yeah. We were joking behind the scenes that snowflakes no two are alike, but you might actually be able to do it with a provider and actually get identical ones.
Yeah.
At which point you've broken science. That's okay.
Kicking goals today. That's good.
Definitely. So with that, we're going to head into a quick 15-minute break. Well, technically 18 minutes. So we'll be back at 40 past or 22, depending on how you want to call this, or 10 past half. Yeah. We'll
the time zone math is breaking my brain.
The time zone math is, yeah, we have stories about that. I promised Jesse one, because, you know, as with many things, as engineers, we double check our work continuously. And so I put all the speaker invites diligently into a calendar, and I made sure they all lined up in, you know, with the buffer for questions and answers. And then they all look good. And I was like, cool, let's send them. And Jesse was actually the first one kind enough to call me out on it. It was saying, hey, event starts at 12, but my invite is for 9 a.m. And I'm like, oh, of course, because yes, time zones, AW, EST, AW, AWST and AEST. And then, you know, European time zones. And I was also trying to calculate for our producer in LA. Yeah. So somebody needs to make a Terraform provider for that.
Yeah.
There you go.
It's that kind of math is just not me. Yeah.
I'll write the documentation.
I'll take it. Yeah. So good though. Yeah. Thank you, Bruce. And we'll be right back.
Thanks, guys. Appreciate it.
Welcome back. Hope you got to enjoy your break for 10-ish minutes. Yeah, something like that. We're back with our next speakers. We've got 4 more amazing sessions for you, which is going to be a ton of fun. I'm excited about this next one. Leaf, so you used to be an air traffic controller, and my sources tell me that you switched to SRE work because it's less stressful.
Correct. Yeah. As I said, IT is easy. You just sit in a chair and press buttons.
I love it.
I think I talked in a recent article about how being an air traffic controller, that was my first job out of school. So I didn't know what a real workplace was like. And it's a very stressful environment. So I just thought that's what work was like. And it wasn't until I left that I realized that I'd been stressed for 7 years. Yeah. It took me a year to unwind.
I can see how the stress levels are slightly different.
Yeah.
Clicking buttons. Yeah, definitely.
Yeah. Putting planes together, that's a problem. Yeah.
Yeah. The impact of respinning your infrastructure versus respinning, like a transport safety board inquiry. Yeah. Different worlds.
That's right. Yeah.
But thank you for keeping people safe and for deploying good infrastructure.
Yeah. Thank you.
Whenever you're ready.
I wouldn't go. I wouldn't go and say good infrastructure. Let's just have a look and see what the talk goes. I've known Leaf a long time, and I've seen some good infrastructure and some very good infrastructure. So let's see which one it's going to be, good or very good.
Let me share my screen and let's get this talk started. All right. So hi everyone. This is my talk about how I get more done with less in Terraform. I just introduce myself. Let me introduce myself. So I'm a senior engineer at Lab 3. I've been doing Terraform and Azure for about 4 or 5 years now. And now I have the pleasure of working with Lab 3 and doing the same thing with a number of clients rather than one client at a time. I'm going to talk in roughly this order about what problems I am solving. I have an extra slide in there about what problems I am not solving. I'm going to talk about how a lot of people sort of getting started with Terraform and trying to do the best they can end up. I'm going to talk about where I think you need to take your code to become more efficient and more relaxed with your time management about trying to get all the things done. And then I'm going to introduce 3 phases to cut from where you start out to where you need to be, and then some suggestions from where to go from there. And then there'll be a short demo. All right. So typically, with the work that I do, I'm building out environments to support product teams or application teams. So an environment is hopefully, is a tightly designed thing. You know all the components that go into it, but you're going to replicate that work a couple of times. You're probably going to build a dev environment, a test environment, and a prod environment at a minimum, and then it tends to expand from there. And sometimes you can be building an environment for each developer. Those environments evolve over time as the product or process evolves, so you need to evolve them. You want all the environments to maintain the same shape. I try to vary between shape and size, so you want them all to look like an apple, but some are small apples and some are big apples, and some of them are ginormous apples. But they're all just an apple, and you just want to maintain the shape and just plug in the varying pieces through a config arrangement. You want to be able to support that your team gets bigger, your service gets bigger, or the use of your service or a process or application gets bigger without you having to work harder every time that happens. So that's what I'm trying to solve. I'm not solving the problem of you building enterprise-wide services, your initial cloud adoption frameworks or your cross-enterprise compliance controls or cloud controls. That's a different layer. I'm building potentially on top of that, where you have an individual team that you are trying to help out. So yeah, here's an example of what you might see if you were looking at someone's code base. You can see dev, test, and prod are in there. And then there's a few other things in there that muddy the waters. Is prod new the real prod, or are you still in progress? Are you using test temp right now, or is it just a bug fix process? And Matt's gone in there and made something that is like an orange instead of an apple. So that's a pretty typical arrangement. What you typically see when you actually start digging into there is that there is no alignment to a design. They've grown organically. There's probably large amounts of copy pasta going on. There's no modules as far as you can tell. The CI/CD, if it is there, might be different in every case. Some might be using GitHub Actions. They might be using Azure pipelines. They might be using a code builder in AWS. Who knows? And the storage of the state for your Terraform might be different in each case. Dev might be your local storage. Prod might be stored in an S3 bucket. Test might be going out to a remote storage of somewhere or in a database. You just don't know, because every single one of those directories has really no relationship to each other. That concept and where I kind of went with my development of my infrastructure was inspired to a large part by this talk by Nikki Watt, where she talks about evolving your infrastructure with Terraform and getting out to the Terra services model and so on. It's a very interesting talk. And she talks about that initial assembly layer and accidentally deleting prod when you made an innocuous change and so forth. This is where I think you need to be. It's very clear that you've got a configuration that describes the size of things. You've got one definition for an environment, which is the shape, and you're doing some sort of module assembly to get as much reuse as possible. If we have a little bit of a look inside config, we can see we've even split the config out to things that in global, they don't change no matter what environment you're talking to. Subscription, that might be a little bit of an Azure specific thing. You can call it whatever you want, but I typically split that in name between prod and non-prod. So you can rename that as you feel appropriate. And environment is where the definitions for each environment can be captured. So that will contain stanzas that say dev is a 2 CPU VM, test is a 4 CPU VM, and prod is a 16 CPU VM. But it's the same VM in every environment. The same for modules. We can see each component that we're going to be assembling our pieces through. And environment, this is probably a more sophisticated way to describe your environment. Rather than having a one-to-one mapping with Event Hub, Key Vault, and Network again, we're sort of building out what your development team is actually focused on. So they're building out products that focus on data services and event handling. And then you start assembling your infrastructure to support those in each of those directories. My demo is a little bit simpler than this, but that's I consider this kind of where you may want to go to, so you can cleanly map your infrastructure to the process, application, service that you're supporting your developers in. When you're moving from that problematic space that I showed about with replication and no idea of what's really happening, phase one is to create a single environment definition. So you move all your code to a environment agnostic definition, which means there's basically a lot of lookups to say, given the name of the environment, what is the value that I need? And then all of the code just becomes agnostic. It's just plug and play. And we'll see that in the demo. The environment is passed in as a parameter. So you'll use the word dev or test or prod to basically switch through your different configuration definitions. And they will switch you either through prod or non-prod at the higher level as well. And you make heavy use of the module assembly pattern to cut down on the amount of replication. You have that centralized config that I talked about that's keyed by environment, gets keyed by subscription and unchanging globals, regardless of what piece you're building. And then you do module assembly, either with locally defined modules. You might be lucky enough to have other people within your organization who've written modules and placed them into version control, or they've placed them into a module registry, a la the registry within Terraform Enterprise, or it might be calling pieces through remote state lookups and injection, which is quite an advanced usage, which we won't cover in this talk. Phase two, once you've got that single environment definition and you've got some config and you've got some modules, is I'm a really big fan of not having to manage your own state. I much prefer Terraform Cloud and Terraform Enterprise to do our state management for us. Within the solution I'm going to describe today, when you start using workspaces, which is that second block on this slide, there is a complexity. It's the trick that I've discovered. And we'll talk about that in phase 3. We map our environments to the state files for our workspaces. That's all handled automatically for you by Terraform. So you no longer have to work out where is my state file. The use of workspaces is a powerful concept within Terraform. Your Terraform declarations are updated slightly to use a prefix rather than name block, and things get populated automatically for you as you execute the Terraform workspace select command. And there are ways to use environmental variables to drive that as well. If you're not using Terraform Cloud or Enterprise, using the Terraform workspace command populates a variable that you can use called terraform.workspace. I'm not going to demonstrate that today. I'm going to demonstrate the Terraform Cloud version because I think it's more interesting and more effective and more efficient for you as a DevOps engineer. And you need to move to CI/CD. So I'm a strong proponent that all ClickOps access in the cloud portals is removed, and only the service principal or agent is able to make the changes for you. So you have to commit the code and have an agent execute that code for you. You have all readability, but you can't ClickOps anything. You invoke it via DevOps pipeline. But I'm also a strong proponent of allowing Terraform Plan at least to run locally. It helps speed up the development if you can see the effect of your changes before having to commit to version control and then invoke the pipeline. Debugging locally is a lot easier than doing it through a DevOps pipeline. Phase 3, which is where we start to bring in the Terraform Cloud and Workspace support. So I note this here, and it's probably a warning. Terraform or HashiCorp could change this at any point. Officially, the Terraform docs say if you use workspaces, that terraform.workspace is populated with the word default, no matter what workspace you declare. So we have to find a way to work around that so that we can populate the workspace we want to talk to. And we do that by, in this case, I'm using an environmental variable called workspace, which we define within the Terraform Cloud workspace, which we'll see in a moment. You have a variable within your Terraform code of the same name. When you're doing CI/CD, you define that explicit workspace, which helps with the Terraform init call on your CI/CD server. Tying this all together means that that environment gets injected into your code, and all of the mechanisms you've used locally now work on Terraform Cloud. You now have proper state management, you have run management, you've got permissions that you can bring in to execute, to allow people to execute or not execute your code. You can bring in all of that power that Terraform Cloud or Terraform Enterprise bring into you, module storage and distribution and so forth, and have the power of a single code base and switching around it with workspaces. There's a few other bits and pieces in there. I sort of recommend as you mature your code, you can look at how to use modules in different ways. And you can also look at the TerraState pattern, which uses the remote state, but that's a slightly higher concept, allows you to bring in almost aspect-oriented code concepts of injecting policy, logging, and audit on resources without you having to explicitly manage them. But that's a growth phase, if you will. All right, so let's go to the demo. First thing I'm going to show in the demo is my Terraform Cloud setup. So you can see I've got 3 workspaces here. Ignore the Bootstrap one. I've got dev, I've got test, I've got prod. We'll just click into one of them to show basically how each of them looks. The key to this is this workspace variable, which has a value of dev. If we use the power of REST and jump to another one, you'll see that the workspace here is test, and it continues through on that pattern. If we then jump to the code I'm going to present, hopefully this is nice and clear for you. First piece I want to show is our Terraform block. And the important thing here is that we're using this prefix. The prefix is what's going to switch us around between environments. And what we do in the variables is we have a workspace variable that allows us to inject configuration values as we need them. If we pull in our config, you can see that we are looking up our workspace values. So the value of workspace is going to vary between dev and test and prod. Each time you see var workspace, you can think it's just going to be the word dev or test or prod. If we have a look at our config, and the environment one will be the most interesting one here. I've only got one value here just to keep things simple, but you can see when I'm building out my key vaults, I can key what size I want, but the shape is always the same. The variable is what's the environment we're talking to. We have this, and then we basically output the one that matches our environment. Same thing happens with subscriptions. In this case, we are defining a few subscription IDs, a few names, and a few regions. So our non-prod is always deploying in Australia East, and our prod is always deploying in Australia Southeast, and it's driven by the subscription that we pass in. The modules, I won't go into too much detail. They're just completely driven by the usage. You can see here when I build a key vault, it's just basically passing everything off. This is the simpler case rather than the grouping case I was talking about. If we now jump to the more nervous part where we get to a terminal. So I'm in the environment directory here. I use an abbreviation for Terraform, so just keep up with me on that one. I'll show you which workspace I'm in now. I'm in test. So if I run a plan, it's just my alias for Terraform plan. I'm going to reach out to my Terraform Cloud instance and ask it to run my Terraform plan for me against the state that it is currently holding. And it will automatically switch to exactly the right workspace. It will inject exactly the right variable, and it will do exactly the right lookups into my configuration. And we just have to wait for it to catch up to us. So we can see here where those variables were before. We've got test here. We've got our environment being automatically injected into our tags. Everything is going to run exactly the way that we want it to run. And if I now say I want to do exactly the same thing, but I want to do it against dev, there we go. And I run my Terraform plan again. I haven't had to change code. I haven't had to change directories. I haven't had to set anything other than what workspace am I currently concerned with. It will go through exactly the same thing. This one's going to be a slightly more complex output because I already do have some state in there, and the configuration has changed markedly since I last ran it. So it's going to ask to make a lot more changes. But that's kind of the point in a way. You've only got one set of code, but they map to different state files. You only have to think about one code base. And we can see here the right values, again, have been automatically injected everywhere. I wanted to talk about a few extra things that you need to be aware of. When you're talking to Terraform Cloud, it pushes your code up, regardless of whether you're running on CI/CD or running locally. So it's going to upload your code. You may not want everything to go, so you can tell it don't send certain things by defining a .terraform ignore file, which has the normal glob patterns to ignore. There's one other complication. If we go back to my editor, you can see I have, if I just shrink everything up, so you just have to look at the top levels. I've got my environment here. Sorry, I've got my environment definition here. I'm looking at a file and I go up one directory, go over to the modules directory and have a look at the Key Vault module. There's one quirk on this with Terraform Cloud or Terraform Enterprise. If we come back to our settings here, to make that work, you have to tell it whereabouts in the code base that's uploaded you're starting from. If you don't do that, it basically says, I can't find your modules. So those are traps for young players. So that's basically the demo there, switching around between different environments but with one, let me do this, with one code base. I make changes, I just run them through each environment. I just change the config as I need to. And that's basically it. I might be open for any comments that have been posted while the talk's going on, because I can't see them. I know, Taylor, you were quite interested to see how that technique was going to work. What do you think about it? If he's there, he's on mute.
Taylor,
what about you, Karen?
is definitely on mute. Like I'm just mind blown, because I was actually looking at the prefix and was like, how could I use this? I need to find some, good examples. But this is exactly the good example that I was looking for. So I'm happy to say that we are indeed seeing good infrastructure by my standards anyway, which Lucky is probably going to say, it's
there's only good and very good from Leaf. That's all I was saying. There's no bad. There's just good and very good. I was just seeing how he was feeling today. Was it going to be good or very good?
Yeah,
I might, because that's kind of gone a little bit smooth. I gave myself plenty of padding in case there were issues and so on. But because it's gone so smoothly, I'll give two examples of how I've used this. Two different cases. One was with a team with a fair number of developers, and each developer needed their own workspace to develop in. We basically hooked that up to a group in Active Directory, and we had a job that ran a couple of times a day. Would scan the Active Directory group for members, find a new member, like someone new developer had joined the team, and basically stood up a new Terraform workspace, in our case Terraform Enterprise, but cloud's just as easy. Stood up a new workspace for them, told them to clone their code, do a Terraform workspace, select their name, and then they can run their infrastructure and make their changes as they propose development. So every developer got their own infrastructure, but the code base was the same for dev and for test and for prod and so forth. The second example was a machine learning program where the company wanted to run a number of different machine learning initiatives. So there might be an anti-fraud machine learning program. There might be a solar panel energy generation machine learning. There might be something on gas turbine optimization machine learning. So a large number of data sources. Each initiative needed a machine learning workspace, but all the machine learning initiatives needed the same machine learning initiative. They just needed to be separated. All of the code basically used that workspace prefix to separate out, was this an anti-fraud? Was this a generator? Was this a solar initiative? All of the Active Directory groups that got created were keyed off that. All of the databases that were being queried were keyed off that. All of the RBAC permissions were keyed off that. All of the Kubernetes model deployments were keyed off that, and so on and so forth. So we went from weeks, sometimes months, to build a bespoke machine learning code base and initiative to effectively under 2 hours, to say, we've got a new initiative, we'd like to try some stuff. By that afternoon, your data scientists could be integrating with those data sources, starting to partition up their data, generating models, looking for conformance and compliance, deploy them to a Kubernetes cluster, and publish a REST API for the parts of the enterprise to start testing against and seeing if the model was actually going to show some promise. So
sounds like a good Thursday to me.
The other thing, of course, is that you've got a lot less work to do. It doesn't scale by the number of people. It doesn't scale by the number of initiatives. It doesn't scale by the number of environments. You have one code base to look after. You do a commit, and you basically can have your CI/CD start to walk through the environments, start to walk through the deployments, and you become a high-performing team. You can go, we've made a change to the infrastructure. We pushed it out to dev, the tests work. We pushed it out to test, the tests work. We pushed it out to prod, the service now works. You can use Launch Darkly and so on to turn on bits and pieces on and off. But you can go from, we made a change and we think it works, and it's in production in 25 minutes. And you only made one change.
Yeah, it's super powerful. And Karim, I think this is where I've been going wrong. I've been too stressed in this IT job, and I just need to take a page out of Leaf's book and just push buttons whilst I sit down. It's all becoming very clear to me now that that's what I need to be doing, and I've been going about it the wrong way. It just makes good.
As I said,
it's
a
cool
solution
example.
for a particular problem. Yeah,
it is. But I think that I think what's really interesting, and actually is what I mean, we actually worked on that together back in the day, and how we can solve some of those things, right? And I think that what was really interesting was that I guess 2.5 years ago, when you first stumbled upon this, and we're like, hey, look, I've got maybe a dumb question, but it could be a really smart question. You deal with me asking. I was like, yeah, Leif, there's never a dumb question, mate. And you smashed it out of the park with that one. I think now what we're seeing with all the work we're doing in this area is that it's becoming something that's much more needed across, as that's the sprawl grows in terms of the different amounts of streams with that infrastructure. Any way in which you can keep things dry is always going to be of benefit, as long as you are, to your point, keeping within the scope of that specific problem that you've got, that use case, because otherwise it can become quite burdensome if you do need really if it's not such a static problem in terms of a static solution that's 100% repeatable. If you need to customize bits and pieces here, and here, then you need some more flexibility within the model. But I think for a large majority of the problems that we see, it's a really, really neatly and well bundled solution.
Yeah. Some of the challenges with it are actually enforcing discipline on your team. You will have developers come to you and say, I need this just for me, but I don't want it I don't want to have a branch that I'm on. I want to be out on the main line all the time. That's always the conversation you're going to have, is like, well, I don't want to be building snowflakes. I don't want to be putting count if developer name equals Kerem, then do it. Otherwise, don't do it. So it does introduce additional disciplines, additional conversations, but you've got the time to have those conversations and move forward and actually deliver more value, rather than saying, oh, you want me to deploy Event Hub across our environments? That's going to take me 2 days because I have to copy and paste it 8 times. No one wants to pay people for that.
It was always really fishy. Leif was always grabbing more coffees than anyone else, and I always wondered how he found the time to do it and also build these environments. But now that's
because I did less work. Yeah,
that's it. Work smart.
I mean, when you think about that, right? When the code base is the same for all environments, and all you have to change is a few variables. You've got modularization and the abstraction on just the right level. That's what we all strive for, right? Like, that's why we build modules and codify our infrastructure and go away from ClickOps. On the topic of coffees, and we'll get back to the tech, but what is your favorite coffee, Leif?
Well, I'm very, very lucky here. Bendigo does have I live in a small country town about 160 k's away from Melbourne called Bendigo. It's a gold mining town. There is a little bit of a foodie culture here. There's a little bit of a beer brewing culture here. There's a little bit of a smoking meat and beef and fish and so on culture here. We have a few local roasters here. So I pick up different coffees all the time from the roasters because they put down the date and the time that they roasted the coffee, and I'll go in and pick something pretty fresh for the day. I am a big fan of New Guinea coffees. I do really, really like them, but anything that's fresh, really, that's the secret. If you're talking about what's a good coffee, as long as the roast is fresh, so that when you have a good coffee machine and you have a grinder, and we could go on, and I could be a complete coffee Nazi about this. When you get that coffee to express and you see that creamy layer on top and you see those big fat globules which are just pure coffee flavor sitting on top there, that's what you're looking for. Regardless of what it is that you want to drink, you need to have those fresh roasted oils sitting on top there for you to go, that's a good coffee.
So much that, like, +1, we've got, for our audience, it's important to know that we have got a backstage chat where we, deal with technical problems, but like the chat just erupted with like +1s. This is the right kind of coffee, and like I think everyone is just salivating for that coffee right now. It's
if you want to experience Melbourne's coffee culture, there's a thing called the Melbourne International Coffee Expo. I think it's coming up in September or October. It's just imagine the exhibition building filled with people making coffee. That's going to be that is just going to be amazing. Yeah, You'll just walk past it and be having a buzz. But I've had friends go there and they've walked away from there with kilograms of beans.
It's dangerous. So what's the go-to brew in terms of, are you an extra large
if I'm wanting to
latte
relax,
man?
if I'm wanting to relax, I'll have a macchiato in a glass. If we've got time for a little off-topic story, I had a friend of mine who was Italian, but had grown up in Melbourne, was sent for a client job in Rome, was working hard. It got to late in the afternoon. He thought to himself, I really need a coffee. Walked down to the coffee bar. As you can imagine, in Rome, there's thousands of them. Walked in, they said, what would you like? He said, I'd like a latte, please. And the waiters just looked at him and looked at his watch and gone, no. And he's gone, why not? I want a latte. And the waiter goes, if it became known that I made a latte for you at this time of day, I would never work again. So from that point, I learned, okay, Melbourne has a coffee culture. Italy has culture.
Coffee culture. Yeah.
There's a coffee culture, just like, so it's like, okay, fine. You need to from that, okay, need to cut down the amount of milk I put in my coffee. So for me, a relaxing coffee is a macchiato in a glass with biscotti.
Oh, there we go.
This is a good choice. This is definitely a good choice. And it is, I've had similar experiences. I can confirm all of this. A colleague of mine going like, look, it's past 11 a.m. You can't have a cappuccino. Of course not.
Yeah.
Understood. No milk.
Well, that's what he ended up
getting.
getting. The waiter said to him, the best I could do for you is a macchiato. Okay, that's the best. That's as far as I can go. Right. Yeah. The rest is impossible.
And that shows you, dedication to craft. It's not hassling the customer. It's just making sure you have the right experience at the right time of day. And I've gone into genuine Italian pizza houses and said I would like a pizza with these toppings, and they've looked at me and gone, "No, I'm not making that." And it's kind of like, okay, what do you suggest? And they go, okay, we're going to change this. We're going to take that off. We're not going to put that there. This is how you're going to have it. Okay. And it's like, okay, that's how I'm going to have it. I didn't know that's what I wanted.
I didn't know the rules. I didn't know the game.
I walked in here thinking I knew what I wanted, but I'm glad you've set me straight. So you've got to take it with a sense of humor. You've got to take it as a learning opportunity. Yeah.
That's it. It's just that.
I'm the biggest advocate, and Kareem knows this, but I'm a big fan of a magic. That's the go-to for me. The double ristretto 3/4 filled flat white. It's just for me, it's just enough of what I'm not allowed to have, which is the milk, obviously, after 11, right? But, it's just enough, right. and it's good. I'm trying to make it worldwide. We just need to get the magic out there, I think, because it's a good one. But a good macchiato goes a long way as well.
We're working on that. I've got a coffee shop here around the corner that's going to open in 42 minutes, and I'm super excited. My partner is getting me a magic at that point because for us, I'm in Amsterdam right now. It's at 7:18 in the morning. I still got all the coffee left of this day. I still get to have that after this conversation, and that's going to make things even better, right? Like it's the best part, that coffee shop originally from Sydney, they got, I think their slogan is something like born in Sydney and then roasting in Amsterdam at this point. And when I first went in, Melbourne Magic, everyone was confused except one barista, and they were like, of course I know what this is. And that's when I'll be honest, like he told me to get one of those. I was like, he's probably messing with me. Like 3 people were
I
looking
would never
like,
do such a thing. I would never do that.
He'd be messing with if he told you to put like caramel syrup in it or something like that.
Yeah.
Oh, well, listen, just in the last few minutes, I did talk about how we drive off that variable that I call workspace. Don't try to be smart and call it TF workspace, the same as the one that can help you drive the init call. When you do that in Terraform Cloud or Terraform Enterprise, it will tell you we don't support workspaces. So you can't take quite the shortcut that way. You can call it anything you want. other than TF_workspace. So I got caught by that last night. I had a big panic of like, oh, my talk doesn't work.
It's broken finally.
It's
I've been
broken.
waiting, it's
I
done.
go, yeah, they've changed Terraform Cloud and my trick doesn't work anymore. But yeah, just you can call it anything but that.
I'm really keen to see.
I'll share the Git repo that I've got. Yeah, I'll share the Git repo with you, Karam. You can might want to share that through whatever mechanisms. You can just pull it down, run. Well, obviously you can't run it against my Terraform Cloud instance, but you can just change the parameters, set up your connection, and it should just run for you. Yeah,
exactly. And I think quick call out to the TFE provider for that. When you start configuring Terraform Cloud with Terraform, life gets a lot simpler. Especially, like splitting up workspaces into a separate repository, consuming them, just like you showed. It's a pattern we don't see often enough. So I'm really, really happy that you took the time to explain it and make it more visible. And when you get the link to us, we'll pop it into the chat so people can follow along, because yeah, I mean, the more you codify, the easier life gets, and the more time you can spend on coffee, clearly. So,
absolutely.
I mean,
all right.
I think that's
any last questions or queries?
Nothing from my side. All
no,
I want to say is, oh, you go first.
I was just going to say, no questions from Medleaf. I'm blown away every time you discover some kind of tip or trick. It's always fun to watch the magic happen. You're welcome.
See what you did there.
Anyway, I'm done now, Karim. You can take it, mate. I'm going to leave. I'll catch you later.
I mean, on that note, right? Like you kind of have to. Like it's so good. Thank you, Leaf. We'll switch to our next speaker in a couple of minutes. But in the meantime, if you are just joining us, because I know Europe is partially waking up, welcome to the inaugural edition of HashiTalks Australia. If you haven't been up for the past 4 hours, that's totally cool. Some of us have been, and we've had a couple of really amazing sessions so far. And honestly, like the learnings here were solid, like from managing Vault at scale to wrangling CSV in the most mind-blowing way possible to, essentially automating culture by making on-call suck less. I mean, realistically, there's no way for on-call to not be a disruption, but that's okay. Like if it's a meaningful disruption, then at least somebody's taking care of it.
Right, but if we can automate the way in which we get the AI to make sure we don't have to get called, then that's where we're really making progress, right?
That's exactly it. And it's, I'm continuously, like you said, you're blown away by the quality of Leaf's talk. And I want to extend that to the other speakers as well. It's
absolutely.
This is a community event. We're not trying to sell you something. We want to highlight the coolest cases that we come across. And I think we definitely found them. And that is what makes life interesting. For our next speaker, who just joined us, we've got a 15-year Microsoft veteran. That's honestly amazing. We were talking about this, and we had people in our team chat who were like, I haven't even worked that long, let alone at one company. So that's you've seen a lot of changes. Welcome.
Thank you so much. I've seen a bit of changes. Yeah, I joined Microsoft when Windows Vista was launched. To give you a bit of background.
The pinnacle, it's called Windows Vista, the pinnacle of operating systems. A time of change.
It was feature complete. Nothing else needed to be done at that point.
I had the luck to be a support engineer by the time.
Yeah.
There we go.
Absolutely. Well, Arno, thank you so much for joining us. I've actually had the pleasure of knowing and seeing Arno's work for quite some time, actually. I one day caught wind of a specific repository that is very well known now called the AZTF mod. And at the time, I don't even know if it was public when we first had our first conversation about this, but it's grown and it's one of the most used modules and repositories that's available for Terraform on Azure. And it's doing some amazing work, I guess, from my perspective, bringing to life kind of how the cloud adoption framework from Microsoft can, in my view, be used in a true infrastructure as code environment, and how it can be. Weaponized isn't the right word, but I like the word weaponized, and put in the hands of people that can do some real damage for good with it. And I'm super excited for this talk because I've seen this in the wild, and it's pretty awesome.
And Lachlan, not to make us look older than we are, but it was 2 years ago that we started this project, right?
That's right. That's right. But it's quickly become one of the biggest. So it's awesome to see its progress and how much it's evolved and how it's changed with the evolution of the cloud adoption framework as well.
Absolutely,
exactly that. It's. I mean, first of all, 2 years ago on this, they did us way less than knowing Vista and being around when Vista was around. So there's definitely that. But I think, like what you said, like weaponized and doing damage for good, that, like chaotic good intent is what drives things forward, right? So in my mind, anyway. With that, I would say stage is yours.
All right. Let me do the usual con call. Are you guys able to see my screen?
Yes. All looks good.
All right.
We can hear you. We can see you. Life is good.
Perfect. So yeah, this project that I was reviewing a couple of days ago, the recap of what we've done. It was 2 years ago that we started with a bunch of engineers at Microsoft, and we clearly wanted to have some artifacts directly reusable for our customers' deployment, and having not only just recommendations, but directly reusable artifact. And it's all about it. If you look at the cloud adoption framework for Azure, that's really our one-stop shop where everybody, different entities of Microsoft come together to share entities, to share recommendation around why you go cloud, how you go cloud, and in the ready stage, which is the one that we tend to focus as engineer, as architect. We were thinking like, hey, let's put a landing zone and let's put things that we can use directly here, and not just recommendation. And that's really all the journey that we've made. So of course you have all the recommendation on aka.ms/CAF, but also you can see all the landing zone options that you have now. And our motto that I slightly inspired from Microsoft motto, which is empowering every SRE on the planet to achieve more. We have to have big and bold ambitions, but more seriously, one of the things that we're trying to do here is that, landing zone is cool, is usually the guardrails, the controls, the policies, the thing that we do. So this is right, this is nice. But what we were thinking at the beginning is like, since we're going to do this journey and we're going to put the DevOps mechanisms into our customers' environment, we're going to work on fancy standard mechanisms, different technology to deploy stuff. Why don't we take this advantage to enrich that with solution, and not only being happy to deploy log analytics to store my log, storage account to store my long-term log, Sentinel to do the analysis and the CM capacity, but also how could we deploy very complex solution? Things that is, for instance, an app service environment with an app gateway. The app gateway is going to query a certification, a public certification authority to get a certificate, get the certificate, put it into Key Vault, and then dispatch it to the different applications. This is this kind of challenges that we were trying to resolve with our customers, and the kind of problem that we see Terraform super fit to resolve. And as that, enable new ways of working. And new ways of working is basically for our customer, which is working differently, more DevOps, more collaboration between the teams. Because what we were seeing is really all the fancy DevOps activity happening on the let's say app dev team, but on the infra team we were seeing a little bit of lagging behind or lack of agility into some of the operations. So we wanted to see how we can move that and talk to the SRE audience and create the SRE capabilities on Azure, basically with Terraform. So that's a bit of the picture, and we can say it's been quite a journey. We've been really going through this journey of GitOps, even though we love to abuse this term, but really to use Git as an ultimate source of truth for an environment. And out of that, we did a lot of work on the agnosticity that we could have towards the pipeline technology. I would say if customer wants to use Azure DevOps and GitHub, that's totally fine. If they want to use GitLab, if they want to use any other technology, if they want to use TFC into different variations and things that we can do with TFE, TFC, that should work. And really, this is a strong commitment and work that we had over the last years. And this is some of the things that we're going to discuss today. So that's the spirit. But when we're talking about landing zone at Microsoft, there is actually, if you look at it right now on the CAF page, two options. There is enterprise scale motion, and there's what we call start small motion, which ultimately, the idea is that enterprise scale brings first a reference architecture that we see here and a core of design concept and principles, and also an ARM template implementation with our first party tool. And in our team, we're working on implementing all the automation using Terraform and DevOps techniques. But if we look at the reference architecture and the reference model and how it looks like, really the idea is to have some kind of recommendation into different area, like the enterprise enrollment. How do we work on that? The management group. Here, how do we create the management group? What is a good grouping of a management group? Putting the policies that will then apply to the different subscription when you will put them into those management group to drive the behavior. So for instance, you see you would have some Corp landing zone. If I zoom on this one, then in this Corp landing zone, probably I won't be able to create a public IP address. In the online, I will, and I will be able to create app gateway and all sorts of techniques and product. So that's really this idea that we have those components, and then we have a set of core components like the identity subscription. So you can see that there's a large democratization of subscription in the enterprise scale reference architecture model, and scaling out based on subscription. So in terms of infrastructure as code, this is cool, and this is actually a lot of capabilities to deploy and a lot of things to deploy. So in the deployment options that we have and that we have done and we have worked, there's all kind of stuff. And usually on the Terraform side, we do start with the DevOps. So as you see here, the H side, when you see the DevOps and platform team, where we create the DevOps VNet, and we're going to talk into more details around that, around things to here store the state. By default, in the vanilla option, we have this capability. But as I mentioned, if you want to use TFC, TFE, that's totally fine. And a set of pipelines that as well could be interchanged. And as well, one of the effort that we spend a lot of energy on is to have the capability to automate even the automation. So if you look at all of these components that I'm showing, it all starts with Terraform, with me locally on my console, or importing some of the stuff on my TFC or TFE. I bootstrap the creation of those components, and step by step, I'm going through the different layers and levels and create and compose a complex environment, which has all those elements, those management elements, but as well as we would call it, the landing zone subscription, which is a bit misleading term, but just to say this is the application subscription. This is where my workload will rely with my load balancers, my different VNets, etc., etc. So this is a little bit for the bigger picture and for what we can do. So that's the enterprise scale reference architecture, and this is our North Star when we're thinking about a good big environment on Microsoft Azure. Now, if we look a little bit at the components that we are leveraging to make that happen. So as we were discussing before, there's really a set of stuff that we put available. And I say set of stuff, let's do a quick overview of that. But ultimately, all of those stuff are absolutely open source. So there's nothing secret, there's nothing Microsoft not available, don't touch, don't look here. It's all on GitHub under MIT license. So you can have a look, you can improve it, submit issues, submit PR. And this is really something that we've seen happening quite early in the phases of the project. Actually, we had Microsoft people coming and contributing, but also customers and partners. And this is really something that was quite interesting to see. But ultimately, if we look at those components, what we have available is really one thing first is a set of Terraform landing zone. Okay, cool. And actually, we have much less than before. When we started, we have landing zone for networking, landing zone for what we call foundations, landing zone for Launchpad, landing zone for whatsoever. What we really have done is a lot of simplification. Remember in the previous session, we're talking about don't repeat yourself. That's really what we've done. We realized that many landing zones were doing almost the same. So we consolidate those landing zones to do one landing zone for basically now what we have called CAF solution, and you can do everything from super complex networking stuff to app gateway to functions. That's the same landing zone. And this is all created by an underlying, the underlying module that we call the unified module. And also another guy that is the Terraform provider. And the provider was an interesting piece that we wrote, and it's serving one purpose right now, which is naming convention. And it might seem a little bit too much. It might seem, why do writing a provider for that? Is we try to do it with a module first, and we seen it was really not super easy to manage the life cycle of the object. So we decided to go via a provider, and that really allows us to manage much better the life cycles of it. And it helps really in one particular phase, which is when you transition from the elaboration phases to the production phases. Because if you start to give names to your objects in the elaboration phases that looks too much like the production, you know the problem with the name that will conflict in names that must be unique, like in key vault or storage account. So with the provider, we just give actually a quick option to the landing zone to just say, hey, use the pass-through, means I'm going production, use the real names, or I'm inside the elaboration phase. So by default, you had a prefix and a suffix, depending on what you do. So if you have 10 engineers working and doing elaboration phases, then that's okay, because the names are randomized and they can validate their code into their side without caring about the name unicity and stuff. And there's another guy that we call the rover that we have published, and we'll go into more details around that. But if we look at what's available, ultimately everything we published in the registry. So if I look for CAF in the Terraform registry, I'd be able to find the famous ASTF mode, which is the name that we give at the beginning and remain like that. But you can see that this module, the CAF unified module, since October has been used 118K. And the provider, if you look for Azure CAF, then you'll find the provider as well. And you see that's been used again a couple of times, and really when we instantiate that. So that's from the registry, but ultimately it all leads to GitHub, as we were mentioning, because that's a GitHub project. And if you see there, this is where we do the engineering. So we see we have the pull request coming, people opening issues, and there you have issues opened by customers, partners, and Microsoft guys. And one thing that also we wanted to have is the thing is the governance and the visibility of what's happening being in the open as well. So if you look at the GitHub project, you also have the public here project where you can see where we are into the phases, what is coming up into the April release here. where you see everything that is done, everything that is in review, and things that I need to check with the guys why it is not even started at more than mid-month. So this kind of thing, right? And then we have like the CAF Terraform landing zone repo, which is here the repo, as I was mentioning, where we have only the landing zone, so the launchpad and solution. And there's also another one, a third one, and I know it seems to be a lot of repo, but they all serve a different purpose. The module is the real logic. The landing zone is the assembly of the logic together. It's like a three-tier architecture. And if you want, and if you see the starter is really resolving this problem, which is, hey, where do I start? Usually you say, okay, it's cool. So do I do monorepo, multi-repo? How do I put my environment? So here it's just, of course, an opinionated view on that and say, okay, configuration, you have a demo environment. So this is how you start with your demo environment to spin up this environment with those instructions. So a configuration, let's say for my AKS service onto that would look something like that, AKS TFVars. And here we'll see a little bit the syntax in a second. But that's overall the idea of those components being available and instantiable out of the registry, and really innovation happening in the open. One thing that we spend a lot of energy on, and is always a little bit misunderstood or a bit, let's say, difficult to apprehend at first, is what we call the rover. So the rover is actually two things. First is a Docker container, and second is a Terraform wrapper. And when we're using TFC or TFE, we can use either the Docker feature or both the Docker and Terraform feature. But ultimately, what we do with that is, very importantly, a consistent experience on Mac, PC, and Linux, because it contains a version toolset of what you need to run landing zone and Terraform. I think it's all clear to us now when we work in the team. It's hard to deal with different versions of the toolset, different versions of Terraform. And it's really important to make sure that when you are release a version of a configuration or an environment, you are sure that you are versioned. So I've developed code that is made to run under Terraform 14. So I'm sure that everybody runs Terraform 14, and there's not an auto update on my developer's laptop that has migrated me to Terraform 15 yet, because I will do the migration later. So this is what the rover does. First, a consistent tool set on all my developers, and also facilitates the transition to the CI/CD or to the pipeline. And what we mean by that is, as we mentioned, if you're using TFE, TFC, GitLab, GitHub, Azure DevOps, or any other CI, what we really wanted to is being able to completely move very easily from one environment to the other. And for that, we had a journey where we started with a full flat big rover, and now we're running more on the concept that you see in TFC for business. You have this concept of runners and agents that really are mini rover that we create that contains just the minimum to run and execute the operations for us. And it allows us also to work and code everywhere, including with GitHub Codespace. If we have time, I'll show a little bit of that in a minute. And I'll do a bit of demo of the rover and why it's important in a second as well. Ultimately, the module as well is an important aspect. It's, as you see, we have spent a lot of work on consolidating the module. At the beginning, I think like many people, we were maintaining different small modules as part of CAF. And what we realized, it was created very little added value, and it was taking a lot of energy. And one of the things that we were not able to do in a good way is to test the integration of different components. And by that, I mean create complicated stuff, complex stuff like I was mentioning before. So it could be a VM, which the password is stored in Key Vault, which the disks are encrypted using a customer managed key, which is inside a VNet with a private link being enabled, and all of this stuff. And really, what we wanted is to be able to be super fast into the composition of those complex environments. So it meant that the code was actually more complex to write. If you see, for example, an example of the logic of the module, you see that we are doing iteration on everything. So again, for each. And for each, which is try if we see something which is a VNet. If we don't, then just don't iterate. So then don't create any VNet. But then also when you go into this iteration, you'll find the VNet key. For instance, here's the resource group key to map back to which resource group is going to be this VNet location. And a couple of parameters like that. And it's even richer for virtual machine. You see that we integrate all different sort of parameters to be able to integrate that easily. So in the composition model, I have here my resource group key that maps back and said this VNet actually will be deployed into this resource group. So here, this is the key, region 1, the key region 2. And here we're linking this key to this key. So HubSG is the key for VNet. So if I declare 10 VNet, that's it. The module will iterate automatically for you. Now, why it's important? Because this module will spend, again, a lot of energy to be able to consume it as a standalone stuff. So you can, ultimately, what it means is you can prepare your environment as a standalone module, create 1 VM, 10 VM, integrated with App Gateway, integrated with all sorts of features, including the certification queries to some public certification authorities, and automatically test that on your laptop or run that totally independently on your TFC environment. And that's the first option, direct instantiation out of the registry. So if I go to my VS Code environment here, you see that I'm running a very simple code. It's on GitHub, and I'll give you the link if you want to play with it. But it's a very simple example where I just have a module example here. And when I run that, it's just here, you see I'm using all the arguments, but you don't have to. I can remove all the database stuff. I don't really need it. And here I have my configuration. And my configuration is super simple. It's just telling me, hey, create this resource group, create this VNet, and put it into this resource group. Create this public IP address, this key vault, put this key vault access policy. So it's all under declarative configuration. And it's all iterated by Terraform. And if you see virtual machine, now I'm doing the complex stuff. I'm saying, okay, store the password into KV1, create this VNet on this, create this NIC, sorry, on this VNet, those parameters for the virtual machine. And here, those are the source reference image. And the disk encryption set is here for my crypto parameters. And you see, if I do that, I can do Terraform on my laptop, right? And no, I don't. Remember, I was talking about the rover previously. So just to give you a quick overview, if you are in VS Code, every time you put a folder called .dev container, I just copied it here. You see that actually it will declare that, hey, you're going to run an image here from this guy. So I'm going to project these files inside my Docker container. So now I'm opening my remote container. I'm downloading this version container locally on my laptop, and I will be able to run that inside my environment. So now I have Terraform. Now, why it's important? Because you see here, I'm going to test my thing running on Terraform 14. If I want to test the forward compatibility and I want to validate it's working on Terraform 15, I just need to put a rover that has Terraform 15, and I can just switch super easily like that. And I can do the same for checking if it works with Terraform 13. So that's a bit of the thing that we do for the local experience. And it's cool, but I would say it's not the only interesting thing that we're doing here. It's also, I'm going to push that to my VCS, and then the VCS is going to trigger TFC to pick up the module and run and do the plan. But importantly, before that happens, I also need to make sure that my code is correct. So what we do as well with the rover inside our repositories is that we are including pre-commit as well. So by pre-commit, meaning that anything before the commit is even validated is going to be checked to see if it's compliant with what I want. So here you see that rover has TFSec for me. So I can do here my my command, I can initialize, and then I can run tfsec. But here I can also tell to my pre-commit, hey, anytime you have a push that you, a commit, sorry, that you have, then you're going to verify if it's compliant, there's no problem with tfsec, and the FMT is being executed, so your code is correct and it's not too bad. So this is for the local experience, and you see once I'm done with my changes, I can do my git push. And when I do my git push, I was mentioning before that we are consuming that out of the registry and using TFC. So if I'm going to my TFC environment here, you can see that I've created a registry demo. And here it's really picking up from this small registry demo 1 example that I created. It's just really a plan that I can queue manually here. And I will see that I'm just taking the code, so the module with the version I specified. It's going to run the variables, and it will then be able for me to execute and deploy those things on my machine. So needs confirmation. I have my runs going there. I probably can even confirm this one. I can do a confirm and apply. And the plan was finished, cost estimation finished, and apply queued. So in a couple of minutes, you'll see those guy things. So it means that, again, here, I've selected running on Terraform 15. We are running the module, and the module is also already realizing this complex composition that we were showing in the code, which is mapping all those objects together in order to apply the configuration. So ultimately, whether you're running a very simple example here, like creating a VM or creating 20 or 100 VM, it would be the same. It would be the same module, the same logic that would be executed. And as I mentioned, one of the things that we found is really super fast to compose an environment based on the declaration. And we really made an effort so that you don't even have to write code whenever you are doing composition within this module, and also outside of the module within the landing zone. So first way to consume the module via the landing zone, via the registry, a direct module consumption, sorry. Another one is to use it via a landing zone execution and composition model. So just want to show you the way we compose the environment. And this is more like a work in progress, but we have tested it, validated it, and we are now making it work at bigger scale. But ultimately, the idea is that we have created this hierarchy of different landing zones. And the idea is that each landing zone here would operate at a certain level. And this particular level will be having a set of landing zone that will be applied by a set of compute node. Now, what we have done for this particular model is the fact that a compute node is the guy that's going to basically execute the code. And as you mentioned here, in many of our customer environments, they say, well, you know what, I don't want to use public agents. I want to use my own worker agent, my own runners. So this is what we have worked on. And actually, the idea is that you have those compute nodes, they sit within your virtual network. VPC, if you're familiar with the AWS world, then that's the same idea. So it's isolated inside my virtual network. And it's important because then it has access to the workload that otherwise I don't have access with the public IP. And what's important as well is that those compute nodes, they authenticate against the Azure infrastructure. So what I mean is when I'm giving my authorization to my environment, I'm not getting authorization to service principals. You know the problem with service principal, you have to manage their lifecycle, but we're using that with Azure Managed Identity. So it means that we're using the compute node identity to authenticate, and then this is how we authenticate against the subscription. And the authorization is same thing, described by our configuration format. And you see that I put compute node here. I didn't put VM or containers because actually it could be both. It could be a VM using an MSI that is enforcing the configuration, or it could be containers running into ACI, Azure Container Instances, or it can also be containers running inside an AKS cluster with different pod identities to impersonate those different levels of managed identity. And then we can play with the scale up of the container instances within the pod. So that's a bit of the idea. So there's many stuff on this slide, I know, but ultimately the idea is that within what particular level you would have one or many landing zones. So for instance, in level 0, you will find the DevOps fundamentals that I was mentioning, like the virtual machine or the container instances. And inside the higher, inside level 0, sorry, before that, you will also have all the subscription, creation, delegation, landing zones. So creating, whether you have an EA or MCA, you delegate that. And in level 1, this is actually where we will fit most of the enterprise scale component, because enterprise scale, we do a lot of management group, a lot of policies. So in a level 1 landing zone, we call the enterprise scale module that will deploy all this structure for me. But the story continues, because at level 2, we then spin up the networking stack with Terraform native module. Then at level 3, we put our AKS cluster, app service environment, etc. And at level 4, we put this application, more description landing zone. So really the idea is that all of that is done by reading a state up and down, and reading this state able to compose an environment. So doing complex stuff, but enriching from what others has been done. And if you see, the lower level represents, if we compare to operating system, more the kernel mode, and the higher level represents more the apps part. And as I was mentioning, this is leveraging the compute node, leveraging the TFC agent pool part. So remember, if we try to link that to our TFC environment, when you create a new workspace, you can do a version control workflow, which is the one that we know most. We can have the CLI-driven workflow on which I can use to store my state, for instance, remotely. And here there's also the API-driven workflow that I can use, and that could be a model where I integrate the most complex environment. If we go back as well to my previous workspace in a very simple way, remember, when you're going here to the way you're running this workspace, you can do a remote run, you can do a local run, or you can do an agent run. And this is really what we're talking about here. We're talking about having my agent pool. So here, this is a VM or a set of VM running inside my virtual network, my Azure environment. And this means that if I select that, if I save that, then when this workflow will run, it will run with this particular compute host inside my VM. So then it means that I'm able to leverage the MI features and all those things I was mentioning before. So here we have done a proof of concept of that, and we are working on the industrialization of that. Same thing, to be able to leverage completely this capability. And also on the landing zone composition across the different layers, this is the responsibility of the landing zone to show you how to read from one level up and down. So this is really the idea of that by default, we're able to realize that on the storage account for Azure, but we can also do that perfectly and super easily based on Terraform Cloud and Terraform Enterprise. So same thing on that, we have completed the proof of concept and make it work in a couple of customer environment. Now we're working on industrializing the code, sorry, to make that work transparently. So read the state one level down transparently. You just say, I want to do that on Azure Storage Account, or I want to do that on TFC cross-state reading with a data source. So that's really the way we are operating here. It's taking a little bit of time, but I show you a little bit the idea that we want to have here. And overall, the idea is that what matters is learning, creating, composing stuff. So basically start with the module, deploy things everywhere, TFE, locally, inside Rover, inside GitHub Action. Take that into the landing zone field if you are ready to do so. If you want to use the enterprise composition, totally fine. If not, then we're fine with that as well. And ultimately, the idea is that you can do contribution to all of that. And really, I insist, this is really the way we are driven. opening PR, opening issues on GitHub. That's really something that that we're delighted to see every time. Chatting on Gitter, we have guys in the team monitoring that as well. And ultimately, aka.ms/tf landing zone. That's really where we see the code, where we publish the stuff, and where we answer to the questions and interactions. So that's pretty much that. That's what I can do for 30 minutes. We have time for maybe one question, or what do you think, Karim Laklan?
I think we can definitely get through some questions. This was nice. I think anytime we can figure out a way to make enterprise scale architecture not be a huge, headache and make it more structured. Yes, I like that. What about you, Lucky?
Yeah, I think, I mean, there's so many interesting ways in which they've solved some of the bigger problems that you have within that enterprise adoption, right? So, whether it's Rover to make sure that whatever the CI/CD backend is that's available can be used, and, or completing that dev experience as well, and, looking at integrating with CodeSpace and all those things. It's just a really well-packaged solution. And obviously, as you can see from the community and the downloads, a very popular one as well.
That on its own is always nice validation. Like you put out your project and you're like, hey, this might work, this might not work. Obviously, this is more than just a small project, but seeing that kind of adoption, I think, is always amazing, and it's always good because clearly the patterns resonate with the community.
Yeah, I think I do have one question for you. I know, what do you reckon was probably the hardest kind of the hardest thing to end up gluing together? Obviously, there's so many things that have been changing recently with the way in which the management group structures and subscriptions and how policy comes in, and to use or to not use blueprints and all those kind of things. How did you find actually landing on that kind of different level or multi-level model, and creating something that can facilitate those zones at like such that enterprise scale?
Super good question, and the only difficult part would be to choose which was the most difficult. But ultimately, that's a model that we created working with customers. So this is not something that comes from Redmond and we're smarter than everyone. This is not the idea at all. This is really we're working with customers and say, okay, how do you work? How does it work for you? How does it not work? And for instance, we're seeing like 5 levels now, and some customer tells us, yeah, you know what, 4, 5 level, no, it doesn't work. 4 might be more applicable, because if you take the example of, let's say, if I'm running purely only VM, then the level 4 is a bit overrated, because ultimately you won't have any complex stuff for your application config. Maybe it will just be an Ansible run book that you trigger, and that would be it. But if we're in the case of an app service environment at level 3, and in level 4, we just have an application to pick the code from the release drops, and then declare that we want this to be running on 3 app gateway, getting this certificate from this key vault, published internally or externally, then that makes more sense, right?
Yeah, I think that, I mean, obviously your levels kind of flex as you move across the shared responsibility model, right? Because obviously you're responsible for less or more. And it's funny because it's almost the opposite with this model, because as you move further into the ability to codify the application level configs, you kind of take more of that responsibility into how you want to kind of govern that through the process. So it's a really interesting one, because you kind of, rather than that VM, like you say, and inject that Ansible scripts in there, you've got to like, okay, now how do we manage this new problem, because we didn't have that before? Or how do we manage the containers for those kube clusters, right? Yeah, it's awesome to see the progression of it. It really is.
And then the last challenge, I would say, that we spend more time and which is resolved now, or not to mention the future ones, but the one which is resolved now is the standalone module consumption. Because really we were seeing customers telling us, hey, I want to do my SAP landing zone, but I don't have a view on all the underlying layers, so I just need to navigate and go and deploy things on top of it. That's it. And if you see at the AKS also enterprise scale module, this is actually our team that created that out of the module consumption as a standalone. So you can just put That's the combo that you can do, right? You can do an ARM based foundation of enterprise scale. And then on top of that, your apps come with the Terraform module that we've done and then deploy the AKS with the rich composition that we've done. So giving options, basically.
Yeah, well, the flexibility at enterprise is key, right? Because you're going to have different skill sets doing different things. So having the ability to pivot and enable those different ways of working is absolutely crucial, right?
Exactly.
One thing
You
that we
cater for
learn
the
is,
group, right?
One thing that we learn is we're never right. There's always going to be a new way that we need to accommodate.
Right. Exactly.
That's
So you
fair
give
enough.
options.
Yeah. I think that's definitely the clearest takeaway is, like, make sure your code is ready for the groups you're going to be interacting with. And, you only get that through soliciting feedback like you're doing. So thank you for sharing. Very, very nice insights. I've got some new patterns that I need to see how I can work them into my code.
Cool, and break them and give us feedback.
Definitely working on that.
Thanks, Arno. Thanks so much.
Thank you so much. We've got our next speaker right here, Code Cowboy Scott. So former systems engineer and current solutions architect at F5. There we go.
Hey, everyone. How are you?
There he is, out of the darkness, he emerges.
Yeah. This is my life, right?
Yeah, I was like, it was dramatic entrance, like they were waiting for the video to show up. It was like a silhouette, and then like just in pops Scott, like bang, there he is, front and center. How you going today, mate? Had a good day?
Yeah, pretty good, man. Been getting heckled by Jamie a lot, so I'm looking forward for that heckling to continue. I'm okay with being heckled too. Yeah.
Well, in that case, we'll just randomly unmute while you're giving your presentation and ask questions and pop them in. I'm kidding.
Yeah, that's fine. I don't mind. Let me share my screen for one moment.
Okay. I mean, you can share it for the whole session if you want to.
Yeah, that's it. I'm really keen to see kind of what you're going to be doing here, Scott, because there's a lot of changes that have been happening within how console and the Terraform sync with it going GA and how all those things kind of can work together. I'm super excited to see what you've got to show for this one.
Yeah, definitely.
So this is really interesting, right? And I came across this while it was in beta, right? And I sort of fooled around with it, and what hit me more than anything is what it means. Do you know what I mean? And the ramifications of doing this. So it's pretty cool. So this is what I'm going to be talking about.
Awesome.
Console, Terraform sync, NIA, et cetera, et cetera. It's a lot of stuff. Little bit about me first. So I'm Scott Van Kelken. Everyone calls me SVK. It's a bit easier. I'm pretty privileged. I help run a few meetups, which is nice. I'm super, super passionate about open source, not just software, but data as well. I'm really interested in event-driven architectures, right? And that's both for software, and I have been doing that for a long time, and now for infrastructure, right? Some of the logos down the bottom, I'm sure that you'll know some of those. That's the sort of stuff that's interesting me at the moment. If you can pick the one on the far left, I'll be very surprised. But if anyone can pick that, you get a prize. There is no prize. It's just kudos. Let us know if you know what that is. Jamie, you're not allowed to say, because I think you should know. So what is all this, right? So I don't know if you guys noticed, but the world sort of went event-driven while we weren't looking, right? In the software world, it's been event-driven for a very long time, right? Events trigger actions, not the other way around. Software's been there for a while. Now infrastructure is becoming event-driven too. And like I say, the ramifications of this are just massive, right? And they're massive from a code perspective, they're massive from a developer perspective and a pipeline perspective as well, right? So I stole this from the web page of Console Terraform Sync. It just sort of says, HashiCorp's network infrastructure automation, blah, blah, blah. Lets your network admins build stuff that automatically apply network and security infrastructure changes, right? And the key thing there for me, anyway, is that it's reacting to changes in the console service catalog, right? And this will make sense as we go through it a bit. And I explained this to one of the guys in the office the other day, and he was sort of scratching his head. And then when I showed him, he went, ah, that's super sexy, right? So it takes about 10 minutes to wrap your head around, right? There's a couple of pieces to the puzzle here. You know, HashiCorp have come out with some really interesting adjuncts to existing products, right? And clicking them together in a way that allows you to move to this event-driven model, right? You know, you've got Consul. I put my hand on my heart. It's an old friend. In terms of NIA, it's acting as a service catalog, right? Which is really cool. Consul Terraform Sync, that's a new friend, and that connects, it's like a little daemon that connects to the Consul service catalog, watches for changes and triggers actions. And that's that sort of event-driven model that I was talking about. And then, you know, we've got a very old friend, Terraform. You know, the actions that get triggered from Consul Terraform Sync, they're called tasks. They are effectively, you're just running Terraform, right? And the Terraform that you run is driven by the Terraform Consul Sync. You actually tell it what to run in a task. And I'll get into that in a sec. So what I'm going to sort of show you in a few minutes is, you know, I like Terraform Cloud, like a couple of people today, makes my life easy. You know, I don't have to worry about too much when I use it. I've pre-deployed some stuff, and I'm just going to show you the app side. So I actually built everything using Terraform Cloud. So I built Consul server, you know, et cetera, et cetera. But I'm just going to sort of talk through deploying my sexy app. And then, you know, that app has a Consul client on it. That's going to register with Consul. Consul Terraform Sync is going to listen for changes, right? And we tell it what to execute as part of an HCL. It's going to execute some Terraform. And it's going to configure my downstream network device. I've only got one task, but you can have multiple tasks. So I've done that as well. And I've done multiple tasks across multiple devices as well. So that's really interesting as well. So effectively, the idea is, right, that you apply changes over on the left. You've got a Consul client embedded in your app. It registers. And then there's other stuff as part of your ecosystem, right, that happens or needs to happen, right? And they ripple out auto-magically to those downstream devices. If you think about that, that is super, super cool. And the reason that it's super, super cool is, you know, you get a bit of separation from a code perspective as a developer. I don't need to worry about that stuff on the right-hand side here. I just need to worry about the stuff in my app, making sure that it registers successfully. And if I see it in Consul, I know that all of this stuff on the right-hand side has been taken care of, right? And that is super sexy for me as a developer. Just, I get on, I want to deploy my application. You know, there's certain things that I don't want to really have to think about too much. And it takes the brittleness of some pipelines that I'm sure we've all seen, right? It takes that away. So if you have a bit of a listen, right? Event-driven architectures like this is where you want to be, right? It lets you push config to downstream devices, reduces your friction as a developer, makes you a bit speedier because, you know, presumably someone somewhere has written a provider and a module to interact with that downstream device, and you can just use it. Even if you're writing a custom one, that's okay too, you know, you can do that, but it's taken care of, and you can just, as a developer, you can consume that, right? And it makes everything repeatable, like, you know, like we're all here to sort of do. You know, you don't have to wait for any changes to be made by anyone else, right? And that's really important when you start dealing with some of these funkier devices out there, right? So, you know, everything's the same every single time. And that's really where you want to be. So on my app side, and I will get to the demo eventually, on the app side, right, it's a really, really simple configuration. It's just really a standard service. It's not very intelligent, right? It's just a web service. The interesting part for what I'm going to show you is the metadata tagging, right? So the module that I'm going to use expects data to be, or expects your service to have metadata, right? And Consul Terraform Sync consumes that metadata, and then, you know, we pass that as variables into the module that we've written to configure the downstream device, right? It really is that simple, right? I say that, but it took a little while to get working, right? But it took me about, I reckon when I first came to this, it took me about an hour to get it working, right? Consul Terraform Sync has a config as well. Now, if I just skip back, right? So, you know, that app side config, that's sort of this part here, you know. Consul Terraform Sync is over here, right? The console config is just whatever, right? You know, the client, we presume it can connect. So Consul Terraform Sync here has, it's a daemon and it has its own configuration. And this is a standard HCL file. And it's got a few bits in it, right? So it's got a driver, you know, up the top that sort of configures the sub-process and to relay any discovered information to Terraform, right? So, you know, that'll discover the metadata and then it'll push it into Terraform. The console server address, that's actually just what I'm sort of checking changes against, right? That's my console server. The provider is the provider that I'm going to use to configure my downstream stuff. And that's an existing provider, right? There's a bunch of them. And then tasks, and the tasks are really interesting, right? So the tasks, these tasks are executed when any change is detected in the service that I'm configured to listen for. So if I go back to my diagram, right? So when if I were to spin up 5 of these as an example, that would be a change. If one of these dies, that would be a change, et cetera, et cetera. And those changes would register inside Consul, and then Consul Terraform Sync would listen for those changes and be notified of those changes, and then take action based on that task stanza down here, right? And what it's going to do, it's going to use this provider and it's going to use this module, right? And it's listening for the service named web. And if I go back for a sec to my service config, you can see that my service is actually named web. Thumbs up. You know, I've got that provider there, and I also happen to have this particular module as well, right? So that task again, you know, that task is really getting that metadata, and it's using that metadata as an input into the module, right? And this is just a bit of a look at the underlying module, which is here. It's just a standard Terraform module. You know, there's nothing special here. I'm passing in, I'm sort of parsing some metadata here and then just flicking it on, and the rest of the module sort of compiles a configuration and deploys it, right? But it's really that, from a developer perspective, it's the metadata that's important, you know? So without further ado, I'll just walk through what I've got deployed, right? So I've got Consul Terraform Sync running as well. I've got Terraform Cloud, which is where I deployed everything from. I've got 10 web servers running with my super sexy app. I have Consul. Each one of these is registered under my service, and my service is really sort of cool because you can see the metadata there on my individual service instance. So, you know, this is the same metadata that my module is going to expect to receive, right? And Consul Terraform Sync is going to grab that metadata and then, you know, push that down to the module as part of the task. And then I've got my bit of network infrastructure here. This is a traditional piece of network infrastructure, right? It's sort of cool, does its job, but it's not something as an application developer that I may have a lot of knowledge about, right? So I just want to be able to interact with that in a really neat way. And I can see there, you know, I've got my 10 things deployed there. Now I can go back to my Terraform Cloud. I'm going to actually spin down 8 of my web servers, right? And this is not rocket science. Just let me kick this off. You know, this is just going to reduce the number of web servers that I've got running. And it's the intention here is really to sort of show you, you know, this is an event that occurs, whether that's an addition or whether that's a removal or whatever. Down the bottom here, I've just got an SSH window that's running, and that's the console Terraform sync log. So what that's going to do, it's like a daemon. It's already running. It's going to query. It's constantly querying console for changes. And when a change occurs, like I'm going to destroy a couple of my web servers, you know, that'll be reflected in console. They'll time out after their really short health check. They'll become unhealthy. And then at that point, console Terraform sync down here will kick in, and that will start to deploy changes onto my network device. And that's the first one. So we're modifying, you know, we can see if I flick back to my web server service here, you know, I've only got 2 instances left. They're going away. And my console Terraform sync here is, you know, busy applying changes automatically. I don't touch my network infrastructure. I don't need to. I don't need to understand it. I just need to know that when stuff changes in console, right, I'm going to have those changes reflected in my application here, right? And you can see there, that's happened. You know, I've destroyed a couple of my things. That's been reflected automatically in my network infrastructure, right? Now, from a, I'll just flick back to this for now. There we are. So from a an application deployment perspective, this means that, you know, deploying the application really, really easy from an application developer perspective. All I need to do is register it with the appropriate metadata in console. Every other change as part of my ecosystem, which may be large, it may be small, whatever, it's triggered by console Terraform sync. It's triggered by my update from my application registering itself here. Everything else is triggered, right? And I've only done one really, really simple use case there, but you know, you can actually do that task. You can do multiple of those. The ramifications of this are actually really, really big, right? The ramifications are that if it's in console, then your application is deployed, right? It's just done. And that includes all of the surrounding bits and pieces, right? And that's really important, right? I don't need to have a separate pipeline, or I don't need to have a separate anything to actually deploy those other bits of infrastructure anymore, because console Terraform sync is taking care of the detecting the changes and then deploying to that other infrastructure, right? I only need to tag my service with some metadata. That's very important. As a developer, I don't need to worry about building infrastructure pipelines. That's super, very important, right? You know, those infrastructure tasks then become the way to interact repeatedly with my network. That's sort of why we're here, you know, but most importantly for me is it lets you move to an event-driven architecture, and that architecture where all I do is I deploy something, console picks it up, and then, you know, changes ripple out throughout my ecosystem. That's the important part to me, right? I don't know what everyone else thinks, but to me, that's super important, right? Is I want my change to ripple out from my service catalog, and I want it to ripple out to everything so that my application is completely deployed. I don't have to do anything else, right? And that ramification and that move to an event-driven architecture, I think we're going to see more and more of that, and it's pretty exciting, right? There's a bunch of links around this to sort of get you started. It's not difficult. I have done it not only with that particular device, I've done it with some other devices. It is pretty cool, right? And it means that, you know, getting up and running is really easy. There's a bunch of modules there, you know, have fun. It is fun. And the way that you interact with your traditional sort of network is going to change, right? So that's really interesting. That's all I've got. Any questions from anyone? You know, get in touch if you want to have a chat. I'm fine to have a chat, and I like beer, so, you know, happy to do that too. I'll just try and stop sharing.
I'm going to start with thank you. These are solid patterns. I like it.
Yeah, I mean, to me, event-driven architecture, that's everything. And, you know, I don't want to have to necessarily worry about infrastructure that I may not be conversant with or know a lot about, right? I want that to happen and just work, right?
And I think that's the goal always, right? No matter if it's traditional infrastructure or if you're configuring your on-call setup, it's yes, it should work, and it should work consistently and well. I mean, it seems like a low bar, but it isn't.
And by the way, that icon on the very left-hand side on the About Me slide, it's a New Order album. I'm just being contrary.
In somewhere.
yeah. But yeah, I mean, good. to me, moving to event-driven architecture is like, we've been doing this software for years, right? You know, we've been using, you know, event buses and stuff to shuffle data around, but it's relatively new for infrastructure to operate in this way, right? So be ready to have some pretty hairy conversations with your network teams when you do this, right? Smile and wave a lot.
Yeah, that's great. Yeah, okay, yeah, great. I think that there's a lot of some really cool potential here, and like I was even looking a couple of days ago on this thing called Kata, which I hadn't played with before, and I'm probably pronouncing it wrong, but it's the Kubernetes event-driven autoscaler, right? And how I can wrap Azure function runtimes within that to then actually apply that on us. And I was like, this is awesome. And then I had that exact thought, but network, what am I going to do here, right? But you know,
it's the last area, right? And, you know, rather than holding on to it, look, let's bring it into the fold. Let's bring it into the fold and make it work for us, right? So that's what makes me really excited.
These are still hard problems to solve. And I think, you know, like even baby steps in this area are going to be super helpful. And well, yeah, having something that works based on the events that happen and occur with your infrastructure, no matter what it is, it's just the logical part of that story to me.
Yeah, like I'm a massive fan of event-driven architectures, right? And you know, what I see a lot in this space is some relatively brittle pipelines, right? And you know, developers having infrastructure-based pipelines, well, they don't want to do that, right? They want to deploy their applications, not mess around with stuff that they may or may not understand completely, right? Leave that to people that do, and you know, make it consumable. Yeah. Like, seriously,
I think it is very much that. It's make it simple, you know, like the KISS principle, like keep it simple, stupid, make it work, and don't make me wonder what I was doing if things break at 3 a.m. in the morning.
Correct. Right. Yeah. And I love it. And the Kato stuff I've played with as well, it's actually pretty cool, right? Yeah, so I think generally, like in our industry, we're going to see event-driven architectures move to the fore again. And I think distributed applications are sort of driving that, really, you know.
Yeah, there's a lot of maturity coming around that space now. And obviously as that maturity grows, the adoption kind of really accelerates up that curve, right? And I think that there's going to be a lot of uptake in there. And now that we're in the cloud, it can go even faster and we can do it even easier. And I'm excited for what comes next. Like we've already, you know, we're getting network in the fold now. We can have, then how do we get security in the fold, event-driven security? Because we're starting to talk about advanced SIEM actions now with SOAR and how we can have those automated response to the security events. Okay, well, how can I ensure that those changes now get synced back into my, the smile on Scott's face tells me I'm onto something here. Maybe we need to have a chat off afterwards, see if we can build something along that. But yeah,
I've got another demo.
See, there we
That's
go.
Exactly
I
that,
knew it.
right?
I'm scratching
This
the
is what I
surface
want to
now.
hear. Yes.
Yeah, exactly. But I think that some stuff around that in terms of how I can re-inject my Terraform config from what an automated action that occurs within my scene provider, something I've been playing with a little bit in the background too. And I think there's some really cool patterns that could come out of that too. And then really it's on to what next, what's not touched, because network and security from a DevOps point of view have always been no, subnet mask. I don't want to touch that. Whereas now we can accelerate and enable people to come in and be a part of that. And, we can get a lot of benefit out of that.
Yeah. So, I mean, one of the things, I know I've only got a minute or two left, but one of the things that I certainly have been doing a lot of is DevSecOps pipelines, and specifically, as you say, reacting to events in the application ecosystem, right? That's a cool space, right?
Yeah, and I mean, I think especially as we look within the cloud space and we see that, that traditional networking model as it's kind of hidden to us in a certain extent. So we move more up into that, the level 7 area where we're more directly interacting with that application and how we need to do things. There's so much opportunity within that we can play with. So yeah, super exciting to see what we're going to do within that space coming forward, I reckon, across the board. And then be interested to follow you, Scott, and see what you can invent along the way, because I think you've got a pretty good grasp on it after that talk.
Yeah, so I mean, as I say, I've done this not just with, I work for the Red company, right? But I've done it with a bunch of other stuff as well. And it is really interesting because what we find, as an example, is we see a lot of traditional infrastructure fronting Kubernetes clusters, as examples.
Yeah.
Right. And how do we make those two things work together in a really holistic way, right? And network infrastructure automation is a really good answer,
Yeah, absolutely. Couldn't agree more.
I like it. I hope that lived up to your expectations.
Oh, absolutely. It was fantastic. I mean, some of the insights you had in there within the console and the CTS in terms of how it was operating was great. Some things I hadn't seen before. I'm not the console wizard or the Terraform Sync wizard, but some really interesting ways you were doing things. So yeah, keen to have a crack at those slides if you're keen to share them and, go through them so I can learn another thing or two and keep the learning going.
Yeah, cool.
Always up leveling. Thank you so much, Scott.
No worries. Thank you, everyone. And, as I say, if you want to get in touch, reach out, right?
SVK everywhere.
Yeah. All the way with SVK.
Some stickers, I reckon, SVK.
I love it.
See you guys.
See you. While we get ready for our next speaker, learning is really it, right? And I'm curious how, when you're not attending virtual events like this one, how do you learn? Like, where do you get your new knowledge from?
Well, one, having any knowledge, or saying that I have knowledge is a strong assumption, to be honest. But what I try to do is just get in and break things and try things, right? Is kind of how I learn. I learn by doing so. If there's something I want to do, I need to be solving a problem and working towards that problem. So if that's enterprise cloud architectures, or if that's how in which we would have an app and host that on Kubernetes, I'll get in and do those things that way. So yeah.
Trial and error, blowing things up and limiting the blast radius. That's I'm with you on that. We talked about our learn tutorials earlier. For me, I'm in the same boat. Build some code, see if it works, then try it out. Our team is currently working on a Packer image that does everything that we need for multiple clouds. And we're trying to find, what's the right pattern of making things work, and where should we have abstractions? And that is the tricky part. And people wonder, like, hey, but my module, it's a 0.0.1 version. It's not ready. It will never be until you've deployed it for a couple of times and realize that, hey, that variable that you thought you should hard code really shouldn't be, because things aren't working the way they were intended to.
Should have been. Yeah. I think what's great about having products like Vault or like Terraform or even Vega and these other things is you've got this platform now where you can be deadly and dangerous across a couple of different disciplines that traditionally may have been off limits from you. So, for example, data platforms is something I've been playing with a lot recently, right? And if you had talked to me about that at probably a year or two ago, those are things that were too far removed and things that I didn't have domain knowledge about where I could be dangerous. But now, because I have a way where I can talk across those different platforms and different domains, I can go and learn kind of the ins and outs through a familiar means, if that makes sense. So I think that it's a really powerful way to try to grow your knowledge and grow how you do it in a way where you're still trying to solve those problems. So that's what I really enjoy doing a lot of the time.
Yeah, it's pretty much the same for me. It's figure out what problems are interesting, solve them, and then go from there. In the meantime, we're working on getting our last speaker back, which should happen anytime. I'm super excited for this talk because we're going to be sorry.
I was just going to say, anytime we can talk about GitHub and kind of, secrets management, I think it's a sore spot for a lot of people and something everyone's seen. I think we've all at some point seen something in clear text that maybe shouldn't be there, or even auth into GitHub that maybe was done in a questionable way. So I'm super excited to see how we can look at how can you shore up your security posture with something like Vault and GitHub working together, right?
Definitely, and also talking about the plugin architecture there, I think this should definitely be interesting. I know Martin was on earlier, trying to get him back so he can join us on Zoom. Martin, if you're watching, then you're on YouTube. You should be in Zoom. Definitely join the other application. Just kidding around, obviously, but we would love to see the talk because I think it's going to be a good one. And in the meantime, I see it's always like when you're mid-sentence, messages start coming in. This has been
most valuable ones too that you can't miss. They always come in, in the middle of a conversation.
Exactly that. It's just that you're trying to figure out where to go and how to fill up the time without the speaker, because we can definitely talk about GitHub tokens and there may have been some bad practices that we pre-implemented just to create the use case that a Vault plugin is needed. But I'd much rather hear the story from Martin. There we go. I think the trick here was to mention his name 3 times.
I was about to do the spin just to see if that helped, but
there we go. Good day, Martin.
Sorry, I had insane technical problems there trying to get Zoom working on this laptop.
It's all good. We've had all the joy with Zoom for the first session already. So we're glad you two got to experience some Zoom outages. This is
wow,
very consistent. We're loving that.
It's just it's not normally a laptop that I use, so I had to switch things up, and yeah, I should have.
It's always right before you're about to go on. That's the only time these ever happen.
It's always
keep
that, right? Like, exactly. So if you're ready, then the stage is yours.
Okay, sure. Let me try and share my screen. You can hopefully see that. Yeah.
Yes.
Yeah, we can.
Okay, good. Sorry, it's not ready yet. Let me just move a few things around.
I like the structure there.
Yeah, that's my little org file. So let me make text big.
I think you have the Zoom window on the top left corner. Could that be the case? Yeah, that one.
Let me try and get rid of that thing.
Because what the Zoom does is it overlays it for us so we can see what's behind it.
Right. How is that looking now?
I think that's a lot better. If you can minimize the stuff in the lower right corner, then I think we're perfect.
Yeah, okay. Let me try and get rid of that. Yeah.
Yeah, there we go.
Good enough, perfect. I suppose.
Yes.
Okay.
Thank you.
All right. Sorry about the initial technical difficulties. My name is Martin Bailey, and today I'm going to be talking about creating ephemeral or short-lived GitHub tokens via HashiCorp Vault. So on the agenda today, we're going to talk a little bit about the motivation. So why might you want short-lived tokens from GitHub? Then we'll talk, I guess we'll talk about what it was about that automation story with GitHub that gave me reason to write a Vault plugin. Yep, but ultimately this is a talk about a Vault plugin, so we'll go through the architecture of that plugin and how it works. But more importantly, we'll go through quite a detailed demo. I might skip some steps now, given it's the end of the day, and I actually think I've done too many steps. I was going to set up the plugin from scratch, but I guess we'll just leave that for now. The hope is with the demo, it will inspire some questions at the end if there's time. Okay, so we'll get straight into it. We'll start with GitHub's automation story. You might be familiar with it if you've ever had to try and talk to GitHub's API from outside of GitHub, or even inside GitHub, actually, if you've used Actions, but you're using some more advanced features of GitHub Actions. So it usually starts with a personal access token. These things, hopefully my browser pops. You might be familiar with this screen here, creating these tokens. So these tokens, they have pretty interesting characteristics. One of them for me that was a big bugbear is the permissions are super coarsely scoped. So inevitably you end up needing to give this one, which is the repo access. And by doing that, you've ended up granting full access to all of your private repositories, full read-write access, I should say. People can access pull requests, issues, sorry, the token can access pull requests, issues, the full shebang. And if that token leaks, then someone else has access to all of that. Another less desirable characteristic of these tokens are they never expire. So in fact, the only way to get rid of them is to delete them from your user account. And yeah, they're tied to a user account. So quite often you'll find in organizations that users have tried to experiment with GitHub's APIs, or maybe they've actually invented a critical business process, maybe CI/CD agents, for example. They'll have created one of these personal access tokens against their account. So if that user then gets offloaded from the organization, perhaps because they've moved on from the company, that token goes with them and that critical business process breaks. Now to remediate that, normally an organization will create a CI/CD user. So that's just a machine user that consumes a license seat, so it costs a bit of money. But ultimately you'll find you're in the same position, right? You've got a powerful user with long-lived access tokens that are just one leak away from possibly some reputational damage to the organization. So apps are a relatively recent thing in GitHub. They represent a different way to integrate to GitHub and automate stuff. They have a much better permissions model. So if you contrast this view to the previous view, you can see there's so many more permissions. You can add and remove these individual groupings from the token, much finer grained. Another nice characteristic is these tokens expire after 1 hour. So, and you can't change that. So GitHub will expire those tokens after 1 hour, which is a good thing, right? But yep, another nice benefit here is you install it into the organization itself. You don't attach it to a user. And if you have many organizations under the umbrella organization, then you can share it between them all. But yeah, they are a better automation story, but they are also more awkward to deal with as an end user. Firstly, there are some pretty sensitive private keys that are used as part of a larger token request flow, which, I think this is perhaps pseudocode, but the general gist is you have to use the private key to create a JWT of a specific makeup, and you use that JWT to ask the GitHub API for an actual token. So I think the key message there is maybe there's a pretty sensitive private key needing managed. Okay. So this is a talk about a plugin, and I wrote a plugin maybe a few years ago to try and improve on this security posture with GitHub and to make working with an app easier. So the architecture of the plugin looks something like this. Firstly, you would install the plugin into your organization's Vault, or get your Vault team to do so. And then you mount the plugin at an endpoint, so GitHub, for example. Your users interact with Vault, they don't interact with GitHub. And those users can be machine users, so it could be a CI/CD agent like BuildKite, Jenkins, Argo CD, something like that. Or it could be a human user, maybe trying to do some experimental automation. Either way, they authenticate to Vault using the authentication methods chosen by the organization. So for a machine user, that might be, let's say, Kubernetes authentication or AWS IAM, for example. And for a human user, that might just be LDAP or perhaps an OpenID Connect identity provider. Point is they use the existing pre-approved settings that your organization has chosen. There's no need to deal with private keys and integrating to Vault. Integrating to GitHub, I should say. Anyway, so a request then looks like the user making a request to Vault, Vault handling that complicated JWT work process, to get a token from GitHub. So it mints a JWT, passes that on to GitHub. It mints a JWT, I should say, using a private key that is now securely stashed in Vault, never to be seen again. Nice and a nice tight posture there. It uses that private key to get an actual token from Vault, from GitHub, I should say, and return it. And then the user can go about their merry way with that token. You're safe in the knowledge that that token will last at maximum 1 hour. Okay, demo time. Yeah, I'm always a fan of talks that have demos, so I thought I would maybe showcase some of the features of the plugin. The trick that I missed was I probably did too much setup, so I started writing out all of the steps for installing the plugin, how to get it, how to configure the GitHub app. But to be honest, the repository is pretty well documented. I guess we can leave that stuff as an exercise to the viewer. So what I might do is quickly breeze past a few setup steps. I was hoping to have done this beforehand, but no such luck. Key thing is we're going to run a development Vault instance. So let me start one up on the terminal. And we're going to use this going forward. So that's a Vault instance there. It's Vault version 1.7, and we are just accessing it using the root user. Sorry, I'm moving fast through these slides. I promise I'll slow down once we get to the interesting stuff. Yep, enable the Vault plugin. You'll just have to trust me that the README in the website is pretty good. Last step is configuring the plugin using details I've got from GitHub. We'll be using a GitHub app from my own profile as part of this demo. Okay, configure the plugin, and I can confirm the settings are in place. Okay, let's we'll slow down a bit now, and we'll start to maybe use the plugin, and we'll see how all the different ways you can use it basically. The first thing anyone's going to do really is get themselves a token. So the way they do that is they use Vault command, or they can use the API direct, I suppose. And they can do a read or a write against the GitHub token endpoint like this. All going to plan, I should have in Vault's tabular output format here, I've got the response from the plugin. So let's take a look at this. There's one critical thing here, that is the actual GitHub token. But there's some other interesting things to talk about. Yep, the token expires in 1 hour. But crucially for later parts of the demo, there's actually a Vault lease ID attached. So Vault, if you don't know, has an internal concept of leases, and you can use that to maintain the lifecycle of something that's being managed by Vault. Some of this other stuff is really payloads that are coming back from GitHub, and the Vault plugin just passes them on through. So what we're seeing here is I've got permissions to read the contents of repositories, to read metadata, to create pull requests, and to read single files. Yeah, so one thing that's worth noting is at this stage, this is an unconstrained token. So this token has access to the superset of privileges that the GitHub app has access to. That's still a massive improvement because it's a GitHub app. It's not a personal access token. So you can constrain what the GitHub app has access to. And I have done so. I've only selected 4 or 5 settings out of the 100 or so that are available. And yes, it expires in 1 hour. So just to set up some demo scenarios, I was thinking we would perform a few operations with this token. So I've got myself a token. Again, it's in my shell environment now. The first thing something might want to do with a GitHub token is probably clone a repository. So I've got a repository in my personal profile for this talk. It contains these notes, some of the images that I use and stuff like that. I've got it checked out here. This is what it looks like. There is a file in this private repository, nothing interesting. It just has a sentence in it that says this is the contents of a file in a private repository. But the point here is if I was to open a shell and try to clone this private repository, we would expect it not to work. And thankfully it doesn't. So that repository is definitely private. If I was then to use the token in my environment to clone that repository. So same clone command, but this time I'm using HTTP basic authentication to tell GitHub about the token. And yeah, I'm just going to clone it to a temporary directory. All going to plan, that should work, and it did. So I cloned a repository using that token. So one other thing that you might want to do is actually use GitHub's API instead of using like Git remote operations. So in this case, I am going to use the token to read that demo file that I was just showing, but I'm going to read it via GitHub's API. So I'll go into plan, yep, that should print out the contents of that file, which as we know is this file here. So that's us accessing a private repository and pulling out a single file using a GitHub token that was given to us from Vault. But yeah, as previously mentioned, GitHub app tokens, they last for 1 hour, which is a big improvement on the perpetual tokens that you get with personal access tokens. But as I was saying, there's a Vault lease attached. If we query Vault at the moment, we'll see the 2 tokens that I've created so far are in Vault, and these are the lease IDs. So you can also see this in the Vault UI. So if I was to sign in as root to Vault, there I can see those 2 leases that are still, they've got about 55 minutes left now, I guess, these leases. But something that Vault gives us on top of all of this is the ability to revoke. So we can revoke tokens earlier than 1 hour, and Vault will do the needful interactions with GitHub's API to tell GitHub to cancel that token on the user's behalf. So, oh, and another thing you can do with Vault is you can revoke all tokens managed in one shot. So a reason for doing that might be a security incident has forced you just to basically wipe all of the tokens that are currently in flight. So I thought I would show that happening in action quickly. You don't need to know what this incantation does, this JQ. The point is it's to show you the permissions that this token that's currently in my environment has with regards to GitHub. And then if we were to go back to the browser, pretend there's a security incident and revoke all tokens under the prefix, which we can see here. We should have seen some action in Vault's console actually. So if I was to look for revoked, there we go, I can see the 2 tokens being revoked in Vault's backend. But then if I was to, just to round that out, if I was to try that command again, hopefully I should see, yep, bad credentials. So we've just used Vault to wipe potentially an entire organization's current in-flight tokens, which is quite powerful from a security operations perspective. Okay, so moving on with the features available in the plugin. It's possible for a user, a consumer, to constrain the tokens further. So they would do it as normal. They'd make a request to the token endpoint, but they can pass a parameters object. And that parameters object gets passed through to GitHub, basically. So you can, as a user, you can ask for a more constrained token, as you should do if you're practicing, least privilege access. So in this case, I'm now going to ask for a token that only has the permission of single file read, which should mean I can still use that token to read that single file, and that works. Okay, so that's the contents of the file. However, that other demo scenario where I try to clone the full repository, that shouldn't work now because I don't have any permissions on. I don't have any permissions on the token to allow me to do that. So same command as before, but with that new token here, cloning to a temporary repository, I should get rejected, right? And that's worked. So the token I'm using has no permissions to clone repositories, so can't clone repository. Back to my slides. Yeah, so another thing we can do here is keeping that client constraint stuff in mind. We can actually force clients to request from Vault a token of a very certain makeup. And you can do that with a Vault policy. So if I was to lodge this Vault policy into Vault, it's basically saying, I require these 2 parameters, and these are the allowed values of the parameters. So the repository IDs must be this number, and the permissions must be pull requests equal to write. There can be no other requests sent to Vault when this policy is attached. So if we were to attach that to a user in Vault, you're probably managing your users differently using a different backend. But if we enabled the normal user pass backend, then and we attach that policy to a user called Martin, then that user Martin can only now make a request to the tokens, the Vault tokens endpoint, so this guy here, that looks exactly like that policy. So if the user Martin was to attempt to just read any token, so get an unconstrained token, they're going to get rejected. If they were to try and just ask for pull requests equal to write, but without the repository constraint, they're going to get rejected. If they ask for different permissions and so on. So only that exact incantation will get past Vault. So that's nice, but the most recent version of the plugin actually takes a lot of that cognitive overhead away from the end user. So there's a new concept called permission sets. This is similar to a Vault GCP plugin, I believe. And the way it works is you create a permission set. So a permission set is a special subpath under the main plugin path. You give it a name. We're calling it demo set here. And then you say what permissions you want that demo set to create tokens with. So in this case, I've created a permission set called demo set, and the permissions are only single file read again. So then the way you create a token from a permission set, very similar to how you would normally create a token, except you don't stop there. So you don't stop at the root path. You provide the demo set or the name of the permission set you're trying to get a token from. All going to plan, I should now get a token from that permission set. And then just to go back to our two sort of usage scenarios, if I use that token to get the contents of the file, we would expect it to work because that's literally the only permission that these tokens should have. I do. I get the contents of the file. Then again, if I try to clone the whole repository, just to round out the proof, it should fail again, right? And it has. So that's great. We've now got a subpath that will return a token of a very specific permission model that the user doesn't have to think about, oh, what do I need to make in my request? They just do as we did above, which is to read from the endpoint or write to the endpoint. Again, you would probably want to enforce that with policy. So the users that you want to allow just to have that single read file permission, you would attach a Vault policy to them. So as I've done here, and now that user Martin, he doesn't need to think about the different GitHub permissions he has to put in his request to Vault. He just asks for a token from the demo set. And that, if you choose, will be the only endpoint that he can call on the plugin. Timing is going okay, I think. Another feature of the plugin is it provides metrics. So they're available in the Open Metrics Prometheus exposition format. And so long as you have network access to your Vault, you should be able to query it and get Prometheus style metrics. And of course, you could wrap authentication around that endpoint if you so chose. The sort of metrics that come back are summaries and counters and gauges of the operations being performed by the plugin. So basically percentiles of how many tokens were created, how many of them were successfully created, were they constrained, were they not, that sort of thing. A whole raft of them. The plugin also has a Let me get that in view. Jump into it, maybe might help. Plugin also just ships with a demo dashboard, basically, that you can choose to use, or you can use it for inspiration, maybe, as you make your own internal dashboards. It's probably worth mentioning that this plugin has, I'm aware of a number of companies that are using this plugin in production, or have been using it for a number of years. We're at version 1.1 now, and yeah, it's been pretty battle tested. So it does its thing, and it does it quite well. And it plugs a few holes in the GitHub automation story. I think we've got time for this one. This is a nice little way that you can use the plugin if you were so inclined. So it's actually possible to write what's known as a Git remote helper. We won't go into the documentation behind that, but essentially, for those that don't know, Git has a concept of porcelain and plumbing, and porcelain is what everyone would normally interact with, so that's your normal Git CLI. But the Git CLI is ultimately calling a series of hidden binaries that are still on your path. That's the plumbing. And often you'll find other porcelains created, so other user interfaces. For example, Emacs has Maggot, and I think there's a product from Atlassian called Source Tree or something like that. Basically, different ways of interacting with the Git plumbing. It's actually quite easy to build one of these yourself. So what I've done here is I've created a new Vault protocol to make Git operations transparently aware of Vault. So instead of going to git clone and then using SSH or HTTPS, you type in vault : / and some magic happens behind the scenes before the plumbing gets called. I've got a little proof of concept script here that implements that. I mean, it's not production grade, but it should highlight the feature that I'm talking about. I guess we don't need to go through this, but the gist of it is it conforms to the interface that Git is expecting. And in between calling the remote HTTPS clone command, this is a plumbing command, it intercepts the URL and changes it up. So it will take in a SSH or a HTTPS. It will take in a vault and it will swap it for an HTTPS, I should say. And at the same time, it will modify the URL and it will call out to Vault, get a token, and slide that into the basic authentication of the URL. It'll then pass that onwards to the Git plumbing. And after everything's done, it actually revokes that token. So I've got that tangled into a file here. And we could give it a shot just quickly to round out the demo. Let me get to the terminal that I was on. So if I was to go back to that clone command, that very first clone command, that's just an attempt to clone a private repository. We know that shouldn't work, and it doesn't. So if I was to swap that to Vault, hopefully some magic will happen. Yeah. So that's that interception going on. So we have intercepted the URL. We've made a request to the Vault plugin. We've got an ephemeral token back. We've then let the Git do its thing. And then at the bottom here, we've revoked that token again. Now the job is done. So that's like an instantaneous use of a permission token and then a canceling of it. Okay, get back to the slides. I think that's it. Yeah, that's all I had. Thanks.
It's almost cheating yourself out of the credit you're deserving of by saying that's all I have. This was amazing. I mean, like you, I'm a fan of talks that have demos, but seldom have I seen a demo that was this well done and well thought out. Because it's hard, right? Like you're not doing slideware, you're doing the nitty gritty. Let's talk about percentiles and quantiles and let's show how this works. And yeah, I'm impressed.
Oh, thanks.
This is a really cool plugin. And I just, while we were looking up the link to share in the chat, I realized that you also wrote the Packer plugin for copying AMIs.
Which apparently gets used quite a lot, as I found out, because Packer just changed their plugin architecture, as you probably know, for version 1.7. And then suddenly I got all these issues raised saying, you don't support 1.7. I'm like, oh shit, people still use this. This is great. So it's 1.7 compatible now. I fixed it up a few weekends ago.
Yeah, I saw. First of all, thank you for that, and thank you for contributing that one still. I've been using this one for a while, and we just got back into Packer doing more stuff with it, and it's nice that the tooling that brought comfort to my operator experience is still available and still works. It's great. That's how you want it to be. It's been like 3 years probably now since you initially released that. I feel like
it would be. Yep, at least.
Good time.
Still does the job. Does one thing, does it well. I
think that's what you want.
That's the best way.
Yeah.
It's like me, Kareem. Documentation, one thing, one thing only.
You do it well, and that's what matters.
There you go.
I mean, switching back to the Vault plugin, it's just the way you can improve your security posture by, having finely scoped credentials. It makes me happy because, like you mentioned it, people go in there, like you click all the checkboxes, and of course it works. And that just doesn't work for you. That also works for the attacker who somehow gained your token. So
I know, it's so easy. It's so easy to make a mistake.
And security is often hard. So I get, why you're like, well, do I really want to go in and create a separate token? Of course you don't. But if a tool can do it for you, then all the better. So I'm very excited about this plugin, and the fact that you've had, it's 1.1 right now. So that's, it's good.
Yeah, the 1.1 was to add that permission sets feature, which is actually really useful. It's allowing a few organizations to scale the plugin to more users or more groups of users within the org. So it's quite useful.
There's definitely so much good stuff in there. I saw like a couple of good issues on there, suggestions on creating a Terraform provider, which can actually be served with data sources.
Yeah.
It shows that people want to have better security, and work like this enables people to have better security posture. And I think that makes all the teams happy. We talked about traditional infrastructure today. We talked about the traditional, developer versus ops, or not versus, developer, ops, security, networking group experience. Yeah, I'm loving it.
Nice.
So thank you for sharing that.
No, thanks for inviting me. I don't do too many of these, so I wasn't really sure what sort of production value you were expecting from me. So yeah,
definitely. Sorry.
Anytime anyone's cracking out Emacs, I like it. Yeah. No, it's a good little way to end it. I reckon. Nice little hark back, and it was really cool. Yeah. And the content was really well covered, and like Kareem was saying, like to pull back the covers on some of the details that maybe is a bit scary for people to do on their own, and actually get a look at how all of those things are working, and even in the behind the scenes kind of chat, when you're talking about the way in which Porcelain's interacting, and there's different interfaces to how that actually works, that's not widely known, and even there are people like, oh, that's right, we got the source tree and all this kind of thing. So it's amazing how much you learn when we get people like yourself who know what they're doing so well and come and share it. It's just a huge value, and then we record it and we share it all around the world, so it's always good.
The good thing is all these videos will live on the HashiCorp resource library. They'll be on our YouTube, so we can have more people get inspired by this and make their security posture, a better one, a more stronger one. And it also forces you to go back a little and think like, hey, wait, so we've been assigning, not finely scoped tokens. We've been assigning, like, hey, here's the keys to the kingdom tokens.
And
how do we change it?
The thing that always gets me is how often have you accidentally leaked a token into your CI/CD logs? I think the CI/CD servers are getting better at like pattern matching and obfuscating them, but man, one leak and that's you've got. I mean, it depends how much you value your organization's source code, I suppose, but yeah, it's not a good posture for some companies anyway.
Yeah, we were talking about that earlier as well, saying, like, you want to share your dot files or something, and you just accidentally, make your token available to the world, and it's like, whoops, I shouldn't have done that.
Yeah.
I mean, GitHub these days, I think, automatically alerts you when you leak your token. But the thing is,
better. Yep. They really are. And I saw might have been just yesterday, at least in the action space, they're allowing you to basically do what we're doing with Vault. So you can request sub permissions on the actions token. So they're
nice.
improving it all the time. Maybe one day we won't need this proxy solution. It's like that classic computer science adage where you can solve anything with a layer of indirection, right? And that's all we're really doing here. Although we are using Vault's amazing strengths like the RBAC, the authentication backends, the highly available API. That makes it pretty special still.
It's also, even if we might not need it for GitHub Actions, the fact that we can still use it in every other place that Vault touches is just beautiful to me.
Exactly.
I mean, pull out the configuration for your GitHub org, feed it into the GitHub provider in Terraform by, plugging together some data sources, and your Terraform no longer needs to know the token directly, and you don't have knowledge of it. And it's not so much about protecting the secrets, more about the convenience of not having to worry about it. So to me, it's definitely, it's definitely that. We had a question from a long-term viewer who likes to join a lot of our streams, Ivan. Are your dot files public? And if so,
yeah, they are actually. Yeah. I'm one of those. What do we call them? Bike shedders, right? Once I touch a computer, no one else can touch it. It's specialized.
I mean, that's good. There we go.
I can send a link. I'll pass it.
I think I got the motion trainer.
Yeah, you should check that one out. That's going to. So it's for Emacs, but there's also some Vim ones. There might even be a VS Code one. But the idea is it helps you practice your Vim motions and get a little bit faster at them. So you stop pressing J, and you use a better motion.
I like it. This was honestly amazing. I'm super grateful, and I'm hoping to have you back for more developer-focused events in the future.
Sure. Glad to.
With that, I think it's time for us to start off with our outro, which means Lucky will do a dance, hopefully.
Incorrect.
Sorry, that's what my notes here said.
Incorrect. No dancing. No one needs that.
I thought I saw that on the main blog. Yeah,
it was just confused because it was meant to be the last thing of your talk, Martin, and then it, yeah. But I'm happy to give that back to you if you would like it.
Well, I think I'm about to have technical difficulties again. I can see it coming.
Convenient. I got a feeling.
Yeah.
I understand. Thank you again, Martin.
Thanks again.
Pleasure. Thank you again to all the people that joined us today for the first edition of HashiTalks Australia and New Zealand. If you don't happen to be from that region, that's totally cool. We have a couple more HashiTalks planned throughout the year. So if you're thinking about sharing something to highlight what your region is doing, please do. We want to create events that are welcoming to people who don't speak a lot or who might just have a use case they want to share with a larger group. And if you think your use case might be too specialized or it might not, be the kind that you should be talking about, shoot us an email. We'll tell you that it's probably still a use case that we want to see, because none of us are as smart as all of us together. And 8 hours ago, most of us didn't have an inkling of what we could do with the CSV functions in Terraform, and not on that level. We've learned how to deal with traditional infrastructure through CTS, console Terraform sync. We talked about improving our security posture in terms of GitHub tokens. Very beautiful. We just had a lot of good stuff. We had an air traffic controller who turned to IT because it's less stressful, which I might be in the wrong IT, but yeah, it's all good. Learning about managing Vault at scale. Also, interestingly enough, with the GitHub provider. So I see, points there. Our ambassador, Bruce, spoke about automating snowflakes, and specifically Snowflake. It was just altogether a really, really awesome event. And I want to thank you all for joining. Martin, you're currently the only speaker that's here, but
yeah.
As the speaker,
take the credit, Martin. Take all the credit, mate.
Take the credit.
Take it all.
Thanks. Yeah, cheers.
These events wouldn't happen without the time that people like you and our other speakers put in, and we're really appreciative of that. So thank you very much. And with that, any closing words from you, Lucky?
No, I just think it's so cool to be a part of such a welcoming community that everyone feels so comfortable to come up and talk, and especially whilst the world's in such a place where we can't have these in-person events that we would normally be doing through our hugs and all the other meetups we would go to. It's really cool to be able to have something like this where we can share all of the awesome work that's going on, and have it something that's just for the community, right? It's not, there's no, and here's the link to buy the product. It's for the community where people are able to show off their open source work or even their enterprise work if they want. There's nothing saying no, but there's no commitment to have to do anything. And I think just being a part of this, I learned so much. So just love being a part of these things, and thanks for having me as well.
Thank you for being my co-MC. This was a ton of fun. And with that, I think I'd like to get our producer Taylor on camera as well for our traditional team picture. And maybe we'll get our team support, Jackie, to join us as well. We'll see about that. Martin, thank you so much.
I'll leave you to it then. Thanks very much for the invite.
Thanks, man. Loved it.
Good day, Taylor, or good evening. I mean, I see the reflection of a light behind you, so that also works. Yeah, it's been interesting, right? Like, we're on 3 different continents, but we're still at the same event, and thank you, Lucky, for guiding us through this and helping us have this fun. Trying to get Jackie in here, but I think for us, we're ready for the next day, and for some of us that means sleep. For others that means getting a beer. Lucky, or coffee. Yes,
that's it. Yeah, it's 5:22 here. It's probably like 8:22 for you. It's 12:22 for Taylor. So yeah, it's a huge effort, but you guys do an awesome job. And Taylor, even with Zoom working against us in some ways, we get through it and make it awesome.
It takes a village, right, to organize this, and I think it's important that there's the 3 of us, but we couldn't have had the fun that we had without the energy that Jackie brought in the back end, the producing that Taylor brought. I like the music. and we'll share that. And I think we'll just wave to everyone. And once Jackie gets her camera up, there we go.
Tired face.
Time for our traditional screenshot. If you've ever been to a HashiTalks and you're wondering like what the hell is happening, this is what happens at the end of the event, because we need picture proof that we've been here because everyone is going to fall asleep. So thank you so much for joining us today. You've been an amazing audience. I wish we could have done this in person, but soon. And with that, I'm out of here.
See you, everyone.